We are live. Hello, everybody. Today is the 5th of December. We're recovering from our turkey overdose last week, Thanksgiving. We'll do the usual around the table for Dallas Robotics Club, and we'll share some projects and ideas that we have and solicit brainstorming. We have a queue started already, which starts with Doug, then Cooper, then Brad, then Paul, then I have something, and then whether he likes it or not, we're going to ask Ray for something. So Doug, I think you get to lead us on. Be prepared for feedback. I think that's what you asked for. But you're muted, Doug. You're muted. Okay, so Doug's first bit is a lip syncing competition. You can. Doug, you're okay. There you go.
I'm good. Okay, so let's see here. Okay, all right. So let's see. Is it insert? Can't remember which one it is. Oh, here it is. And why is this up here? Why is this over here? I thought when you were in slide mode, I thought it was just slide. Yeah, there we go. Okay, like I said, my situation this year is such that my wife is gravely ill, so I didn't really have a chance to compete in the 2023 Robo Columbus, but I've got a whole year. I mean, it's like, it's not, I've got a whole, well, it's December, it's going to be in November, almost a whole year to go ahead and plan this out. So I really would like to compete next year and win a cup. In fact, I'd like to have one that's good enough to actually get a perfect score. So that's what I'm planning. And so I have been spending a lot of time since Robo Columbus and before Robo Columbus working on getting various sensors, communicating, trying to find out. Like, for example, I found an IMU that I want to use that won't work on a Teensy 3.2, but it'll work on a Teensy 4. Just lots of those little weirdnesses that show up. But so I've been doing that. But I decided, well, let's really try to think about what we're trying to do. So if I remember right, push this button. Yeah. Okay. So the purpose of this document, and this is just a private document, is to collect ideals for a successful rover entry and probably other, because I really would like, if possible, since my son lives in Seattle, I wouldn't mind going up there if I had something that was truly competitive. All right. So the first thing I wanted to do, and so this is a brainstorming idea, so there's no ranking per se, but I'm trying to capture ideas. So the first thing I decided was I'm going to divide the robot into separate modules. The intent being that they are self-contained with their own input and output interfaces to other modules. Ideally they'll be able to be if it's executed correctly, they'll be able to be reused easily in other robots. And I mean that by that they'll actually be mechanically as well as electrically separated. The module can be dismounted and mounted on the robot chassis. This means it screws on and screws off. The container will be made of metal, project boxes, something that makes it mountable and dismountable by just doing a couple of screws. And the battery power will be daisy chained from module to module. Now, it'll actually be some sort of star configuration, but each module will have like an XT30 an XT6, is it 60? Yeah, XT60 plug mounted into the case so that you can just plug an extension into it. All right, now it might not be an XT60 because these guys don't need that much power. It might be some other module, but whatever it'll be standard. All the interfaces will be the same. There'll be independent power because since they're going to be able to be pulled off and put on another robot if required. That means that the only connection is to the battery. All the step down converters, whatever's need to condition the power, the bypass capacitors, whatnot, will all be on in the module. They'll also have a ground. Everyone will have its own ground connection, obviously, to make standard ground. And like I say, I'm picturing this as a star, not a true. I put the word daisy chain up here, but that's not really what I meant. What I meant was that they'll be starred off of the battery power. Mm-hmm. Okay, let's see. They'll use standardized connectors. Right now I'm thinking RJ45s now, and Cat6 wiring. Or they'll use ribbon cables with 100 mil connectors. I haven't made a decision on that. The problem with RJ45, it's easy to get. It's got the connectors are easy to get. They're reasonably cheap. So there's some advantages. All of them are twisted pair. They're all low capacitance. There's some real advantages to doing that, I think. And same thing with ribbon cable. It's pretty easy to get. There'll be this is a big one. There's no DuPont style wires or that's probably supposed to be or connectors with one exception, and that would be to go to servos. Everything else, you're going to get rid of all the DuPont connectors on it. And also, even though this takes more time because it means you have to do your own wiring. Probably you'll have to build your own wire. There's going to be a color code, and so right now I'm looking at battery as plus being red and minus being black. Ground will be black. Actually, this may not necessarily be universal because if I use Cat RJ45, obviously there's no black wire. 5 volts will be orange. And again, the same thing if you're using Cat, and I think orange is used for other. So some of this is still real up in the air. I will say this, but they will be using black grounds and red VCCs if I can find it, because you're going to be using, I think it's called stemma. When I'm when I leave, if I don't have the option, and I'm going to talk about PC boards in a minute, if I don't have the option, then I'm going to use stemma cables, and they have a color code. All right. And you can see here I'm already anticipating using RJ45, so the TX would be the orange with the white tracer, and the RX would be the green with the white tracer.
So, Doug, do you want feedback and thoughts as we go, or at the end?
Well, I can't see anything right now, so if somebody's out there waving their hands and trying to talk to, I can't see you. All I see is the screen that you see. So I have no input into what everybody else is. So just say, hey, I got a comment or something. Just jump in because I can't see you guys.
Okay. Well, I have one question for you, and that is on this connector thing. At first I was thinking initially these RJ45s and Cat6, they're kind of chunky, but then I was thinking, you can get Cat6 in so many different lengths and stiffness and flexibility and whatnot. And Cat 6 is also, it's got the PoE standard. So, so I was wondering, do you intend, and you mentioned that you wanted to build your own so you could use color codes, but were you thinking
okay, I guess when the wire codes there, if I use Cat 6, I'm going to be using the Cat 6, which I believe, if I remember right, it's kind of like it's orange and brown and green and blue, and then the thing with the stripes. I'm going to talk about that a little later.
Okay.
So between modules, in the ideal world, the module attaches to the robot with 2 screws. It has 2 connectors. One connector is battery power, and the other one, which is going to be 3S, so I'll dump it ahead. Then the other one would be the RJ45 connector. I would be using, how when you buy I'm sure everybody's got a collection of Cat 6 Ethernet connectors. And some of them are very floppy.
Mm-hmm.
So what you can see here, or think of it, is you probably have one end that's built in already. You cut it to length. You make the other connection on the other side using one of the standard connector kits that you can get. So you're gonna probably always end up cutting those cables off, and because that way you got them already, so you don't have to put a connector on one end because it's already there.
So you're thinking flying leads then, basically. You'll solder at one end or something.
Well, no, I'll put it in an actual RJ45 connector. I'll remake the other connector.
I will throw out there, so it's funny, my presentation is gonna I'm not gonna make a lot of comments because my presentation is actually concerning a very similar idea. But one of the things that I was gonna throw out there is that I've got this old MakerBot motherboard that actually has those RJ, these are 485, but similar idea, using those as the main data transfer between the interconnected boards.
Yeah, and that's what I Cooper, I think that's a good thing. I mean, I know Vex did something like that with their non-standard RJ40, and I actually ought to probably review their old connectors to see what they did. I know they used a lot of I2C on their stuff, but I'll have to check that. That's a good point. All right, so again, I have a robot code base for a lot of the stuff that I'm going to use, but I want to, since I've got a year, I want to go ahead and migrate it to a simple, embedded style C++. Okay. If I can, I don't know. I think it's something that I can do. Right now I use pretty much structures and pointers and functions to emulate classes, and I want to take it from the C to actual classes in C++. But I don't know how much learning that's going to be for me. Might be a lot. Okay, looking at batteries, I would like to go to 3S, but I've got a slew of 2S batteries, but this is where I really want to go. To keep costs down, 3S is preferred for a lot greater flexibility in the selection of motors. All right. Then, and remember, this is brainstorming, so it's a little disorganized. I'm going to have this assumption model task, and I'm really looking at just essentially four tasks. Obstacle avoidance, drive forward, which would be the lowest task, and C-cone, So if it sees cone, it would go to that and have priority. And then one would be post-cone hit. So that would be looking for a bumper, probably a bumper hit while within distance of a certain error circle around a cone. Okay, so if you get close to the cone and you get a bumper hit, then that might put you into post-cone hit and waypoint choice routine. It would cause that task to be selected. Okay, so here I was actually trying to think out, okay, module wiring with Cat6. And a ribbon is a little, I'm not, that's kind of like a fallback if this doesn't work. So if you look at some of the standards, orange and green are used by serial port. And right now, the only communication, I'm going to do communication between modules with serial. Now, I would like to be able to do it with CAN, but that I'm learning a few things up here, like C++, working with the C++. I don't know if I can get to CAN bus this year, but I also got, it looks like a bunch of empty leads. So, I'm not using the blue and I'm not using the brown. So there's plenty of potential growth for wire. All right. Okay. So the electronics are going to be on custom PC boards. Now, when I breadboard, I frequently use homemade PCBs. I don't like to breadboard. I just get in KiCad, do up a PCB, and etch it here at home because I can get that in about an hour. But I want to do that to check it out and send it to PCBWay or something similar. So the design will be using CAD, and the strategy will be, I'm going to use as many modules, and I don't know if you can see me because I don't know what part is this, but okay, like this is a module. Okay, it's just, this one happens to be an IMU module, but it's just a module. So it will sit in something like what you're seeing here, which will be into a motherboard, which will include such things as pull-up resistors, power in, power conditioning, whatever sensors are connected. If there's another sensor, it'll be, unless the sensor requires being mounted in a place. Like for example, if you have one of my GNSSs has a chip antenna, so it really shouldn't be put inside a metal box if I want to actually get reception. So there's a few things like that. I do have some that have an external antennas, and I might just go to that. We'll see how that goes. So the idea is that the PCB is actually a motherboard for the other, for modules. And by this, I should say, I'm not talking about the modules that are the modules of the robot. I'm talking here about the little cheap modules that you get that make your job easy because you don't have to make a PC board of all that's emulating what's already on the module. And I'm probably also going to socket for easy replacement if possible. I really want to use, and my original idea was to use some servos to allow obstacle avoidance to be more flexible, but right now I'm thinking of using no servos for simplicity. We'll see how that idea is. And then for screws, I know there's probably a lot of metric guys here, but somehow I ran into, I've got like 1,632 1/2 screws. So that's going to be my standardized screw if I'm with a Phillips head as much as possible. Now where that'll vary is if I do use any 3D printing with inserts, that'll be 3mm because that's the inserts that I use when I do 3D printing. Okay, so here's the modules. All right, remember these guys are all going to have serial ports connecting to what's going to be the primary controller. So there'll be a motor controller, which will define throttle and steering. It'll use a PCA 9685 to allow, it makes it really easy because it's really an I2C thing. The RC, I'm going to try to use RC escape motor drivers to allow changing to brushless at a later date if I find out that my motors are too small to drive the big wheels. Obstacle avoidance, so these are really aimed, obstacle recognition, excuse me. These are aimed at finding cones. So there'll be an OAK-D light with Raspberry Pi. Right now, in the past I've used the 4, but I've been doing some research, and it looks like possibly a Raspberry Zero 2W might do that. Plus, that might allow me also to do some other things. And I'm thinking of a backup. So the OAK-D light is good, but as you approach a cone, when you get really close to the cone, it's very hard to include recognition of the cone because all it sees is this big orange blob. All right. So you don't want it suddenly saying, oh, I don't see a cone. And one way to overcome that is if I see a cone, I see a cone, I see a cone, and I've got my 0 vector on the cone, then turn off object recognition and wait for a bumper click. Well, that would be one way of doing it, but I'm thinking of adding a blob cone detector for suspenders and belt type of solution. And I'm looking, it'll either be a PixieCam, and actually, I'm not sure it would be PixieCam or PixieCam 2, and the other one would be a MaxBit running Python or MicroPython. So these are the 2 obstacle recognition sensors. Obstacle avoidance, the primary one will be the ones that Scott showed to be so effective this last time, and that'd be the TF Mini Plus LiDAR sensors. Now, these guys can be run either on I2C or serial, but I'm looking at running them on serial because I can see that as being more
so the kind of weeds that Steve has on his property, it seemed like Scott's robot was just running right into the weeds. So I don't know if the TF minis are...
Watch the, well, you don't have them.
What?
Carl hasn't put them up there.
I'm delinquent. I haven't yet put the videos up. But
I'm saying is, I know if you look at what he did, the one that seemed to run into weeds the worst was not Belch. It was Turd. And the Belch had the TF Mini Pluses on it. The Turd had, I don't even know what. No, I think it had the micro time of flight sensors, I believe, and those seem to be failing him. But anyway, and
so
I'm also
one platform did all right then.
Yeah, I think it did okay, but also I'm going to use some polar distance sensors. Those ones, they're time of flight too, but I'm not sure what the sensor actually is. I usually refer to them only as their part number. This guy has a 12 meter. Yeah. So this guy can actually help you use your assumption model to avoid the obstacle ahead of time. Do you know what I'm saying? Mm-hmm. This guy has got maximum of 3, but I think it's 1.5. So this guy is this might be more of a, oh man, I've got a whole bunch of weeds all around me. Do you know what I'm saying? And this other one might be the sensor that if you're in the weeds, this might help you. But I'm also, if you look here, this is how I'm trying to get around that, Ray. Yeah. So the first thing is I'm trying to get it this assumption model to see it before I'm in the weeds. All right. So it would use probably the 15 and the 45 to make a decision of how far to turn based on what it saw as it comes, because it got 12 meters, you know what I'm saying? So let's cut it off and say, well, it sees 6 meters. Okay. And so if it sees 6 meters and you're coming up on one of those edges, those grassy edges, you're really hoping that it'll trip on something and direct you away from going into the weeds. All right. And when you're in the weeds, the only thing that you can hope for is your bumper. Okay. And then if you're in the weeds and you hit the bumper, then I believe that I think this 45 is enough angle to help you to get out of it. You might even need a 90, but if I use 90s, they won't be they won't be TF minis. They'll probably be polo distance sensors. And what's not in here and should be is there will obviously be a front bumper. Okay, so location. So I've got 1, 2, 3, and 4. So location, and it's going to have GNSS, IMU, and if it's easy, since if I'm using Pololu 37 millimeter motors, I'll have encoders, so I might throw them in there. And I really would like to learn how to do a single direction, which would obviously be yaw, common filter of the inputs from these three. I found that, so I've been I have 2 decent SparkFun GNSs and 1 inexpensive GNS a module that I was real impressed with from Amazon. It's the actually M10. The 2 that I have from SparkFun are M9s. The nice thing about the M10 is it also has a compass. So I don't think, I may have actually, because I have them, I may go redundant on these. I'm not just, or I may mount both of them and decide which one I use based on it. I'm also looking at if the problems with the magnetometer on the BNO 055 are resolved by the new new library modifications, or I'll use the WT 901, which I've been playing with, and it seems to give you a heading that you could expect plus or minus 3 degrees without too much trouble. So this is the one Scott used on Belch, by the way. And this is what he used on Turd. They're such odd names, so I have a little trouble with it. And then the motor encoders will be there. Obviously, they'll be there if they're on a brush motor or a Pololu 37 millimeter motor. And then, so that's, whoops, I don't know. Somebody. So that's 4 teleop. Okay, so this is the chick magnet. Well, there's actually 2 parts. I'd like to have a 915 megahertz radio for the true teleop. But I might also, if I can figure out how to put a SSD card on one of your chick magnets, I might do that too.
Yeah. Okay.
Now I might actually might want to team with you on that one.
Okay.
Yeah.
You can get the RC control from a lot of the motor controllers, like a Roboclaw or a Cytron motor driver. If you go on and brush DC, you can get that for free on some of those.
Yeah, well, but that's with this thing up here. It's so easy to do. It's really not. And if you use this, it allows you to double use otherwise if you're carrying a dead man switch, in my case, it's it's an RC auto controller with speed. Well, I can repurpose them, so I can have three modes actually. I can have, okay, the RC controller is doing exactly what it was made to do, driving the robot around, so I can take it from one place to another. I can switch it into a second mode where now the throttle, what it does is it kills. If I have it turned in, it sends a low signal to this board. If I have it out, it sells a long, I shouldn't say signal, long pulse, and that can be interpreted as triggering the safety switch. So this one really, I think this is I'd rather go this way. Plus, I don't want to have to buy a RoboClaw because they're so expensive. But if I end up, or a Rave.
Oh, Rev.
Excuse me. They probably have it too, but they're also very expensive.
Yeah, I know the Citron, one of the Citron has it.
Yeah, that's a Rev product.
It's a high current driver if you're doing a rover.
Go ahead.
Gonna throw in there. I actually bought 3 of the Citron. They're just the brush DC, high current drivers, and I mean they're the most quality bang for your buck motor drivers I've ever used. But then again, I haven't bought. I don't have a whole lot of.
Can you use brushless on them?
So the ones that I bought, no. But I understand that they do have those brushless motor drivers, and I could only assume they're probably just about the same quality.
Okay. Yeah, Rev is good. There's no question about it. I'm going to be looking at some of their things for mechanical. I put together a fairly rough platform this year, but I didn't use it. But I did show that it looks like it could run okay. But that's not where I want to go. I want to go to probably a chain drive, but I don't have much in that yet because I'm still thinking about it, because that's going to cause me to manufacture some aluminum parts that I have to think about. Anyway, so that was teleop. Power, it's got the battery charger, distribution bus, and it has LED status. Start, which has the go button, pre-test with display. So like you sit there in the pre-test, you can check things like, okay, it's the motor turn, does the encoder read, and if it does the IMU change direction as I expect. You do all that in pre-test, and then you hit the go button when you're ready to go. And then finally the primary controller, which I'm looking at a 4.1 because it has 8 serial ports. So if you think about this, 1 serial port, 2 serial ports, 3 serial ports, 4 serial ports, 5. Well, this will be a radio, 5 serial port. This one doesn't require a serial port. This next one doesn't require a serial port, I don't think. Yes, that one does. So that's 6, so 7. So I'm still in the, if this is all the modules, then I should be okay to do serial ports. Obviously CAN bus would make this, and the 4.1 does have CAN bus, so that's another idea. All right, and I thought about this, and I've decided to have internal step modules, and I think that's it. Yeah, okay. I appreciate you guys going over, listening to what I said. Please, okay, I would like is there any comments? Anybody want to go into it, talk about anything? help in any way.
You're going to have a fun year. So
Yeah.
what are you thinking that this will be like mechatronics to add to the base you built for this year, or are you going to start with a whole new?
Well, there's a few things that I have to check out on the base. I've got some 10 millimeter drive belts coming in that I need to see if they really can handle all this and how much weight they can handle. I'm going to brick it up. I'm going to put bricks on it and run it and see, like what is the upper weight limit. And I don't know. I think it's what I got now, I think is good for testing these modules, but if these modules are truly as independent as I want them to be, putting them on another robot chassis would not be an issue. Do you know what I'm saying? So the concern I have, I would like to go and have something that looks more like Scott's robot Belch. So I'm looking at, so on the side of the robots, there's I'm thinking aluminum plate with the shafts going to sprockets and the motor controller and whatnot, and then another plate so for bearing support. So there'd be like 2 plates over here and 2 plates over here, and there'd be sprockets in the middle with chain drive. And then coming out of this sprocket would be two wheel hubs, and coming out of this side would be a motor shaft. And that's what I'm thinking. And then these guys are tied together. So think of it as kind of like a tank with wheels. And yeah.
So what's your main goal? Because you've got so many things to pull from, but you've got a lot of, like, are you out for points? Are you out for object-oriented rebuild, modularity of mechatronics?
Well, I'm out there to lose, Carl.
Okay, this is SmackDown. He's going for full points, pole position.
There you go.
If it works, obviously, I think it'll be real obvious to me as I get deeper into this. Some of these modules, I feel like I'm well on the path. All right. So it means that I've got to do such things as getting the custom PC board, figuring out the case that it's going to go into. That's pretty much it. Other ones are a little more like, and there's magic, so we'll have to see how that all happens. But these modules, I think these tasks and these modules, I think, are good basic design.
Yeah.
And let's just see how, just have to see, like, okay, let's say you had these modules and you had to get away, something has to fall away. Well, it would be teleop. That would probably be my first one to go. Mm-hmm. So if I'm prioritizing these, it'll be object avoidance, object recognition, and location. Okay.
Prioritize in terms of challenge?
No, I don't think they're in challenge. In challenge, I feel I have a pretty decent handle on the recognition one because I have developed an OD-like model that I have confidence in, and doing blob on a Pixie cam is pretty easy. I would like to try it on a max bit to allow binning, a little more binning. I think Scott did a good job on Ray. Ray did a pretty good job on binning there, and that's another thing I probably would like to maybe talk to you about once I get deeper into it. These guys, I've tried these TF Mini Plus LiDAR sensors, and if you're the one trick on that I found was, my initial intent was everything would be 3.3 volts. Okay, that way I never screw up the tiny, because the tiny would never be subjected to 5 volts. Well, there's a problem with the TF minis. They need 5 volts to run. Their serial port output is supposed to be 3.3 volt levels. All right, but I'll be quite honest, I haven't plugged. I've run them off of a Mega without any issues. I wanted to put them into a Teensy, but the thought that if I screw that up, the Teensy will be killed, because Teensy 4s have no tolerance at all to 5 volts. So if you put 5 volts to a Teensy pin, that one's dead. And so I don't want to, I haven't worked up. I'm gonna check it. I'll check it to make sure that they're 3 volt levels. But I don't. There's things like, okay, if they're, well, I just have to check those sort of things. But running these guys, they're reliable and they're dead simple. And these guys, I have already worked for indoor robots. I've already worked out the code for these, so I don't feel too sensitive about that one. The GPS code is fairly simple. I have a BN05. I've used 055s in gyro mode internally. Externally, I've had issues with trying to use the 9 degree of freedom with the compass kind of like going crazy after a while, or not, just going weird. This guy looks pretty steady, pretty rock steady. I mean, he's not super accurate, but what he does well. And encoders, that's a thing I know a lot about. So those are I don't feel too hard, but they'll give me a real good thing on. Motor control, I don't have too much problem with this because I already have working versions of this. Teleop is a total mystery for me right now because I haven't had good success with 915 megahertz radios. And I've wanted to learn.
When you say 915, do you mean LoRa or just a 915 megahertz radio?
Just a 915 megahertz radio.
Oh, okay.
Yeah. Because I'm not sure this could, on LoRa, I don't know if the data packets, they might be too big. I don't know, maybe not. That's an idea, though. It's a good thing to think about. This here, yeah, I mean, Ray, give me a range for this. What am I going to expect in the field?
Okay, I didn't actually use Wi-Fi. I used ESP Now, which you can transmit up to 250 bytes. Yeah. In the packet. Usually you just use a structure, and the structure can contain any data, literally, characters, floats, integers, whatever you want to put in there.
So I talk a lot about that on my presentation later on, so I can
all right.
to that later on.
Okay, one question though. What was the range?
God, I can't remember if it's 300 meters, which is like...
Okay, 300 meters is fine. Okay, that'd be...
I think that's what it is, but I'd have to look it up.
Okay, all right, okay. And then I guess the second one would be how big a battery do you have to carry? But anyway, so this is my most... I don't know how to do it quite right. I was looking on these radios, the radios that they use on the drones that they use on RD Pilot, because I have a set of those. We'll see. Now, unfortunately, mine come from China, and I don't know if they're any good. All right, I guess that's it. I have taken a lot of everybody's time, and I appreciate it. If anybody has let's see, how do I stop presenting? Oh, there it is.
I'll throw in one comment on teleoperation and radio control.
Yes.
I've had very good luck with a very low cost 2.4 gigahertz digital radio product based on NRF 24L01 pluses. Mm-hmm. Those typically run a 1 kilometer range. They're 2.4 gig digital radios. They are highly immune to problems with data errors because they are have a lot of logic built into them to correct and monitor for errors.
Yeah.
They need an SPI interface, which is generally not a problem. I've used them with Arduino Nanos with good success.
Yeah.
So you may find that worth looking into. It's basically
Can you? Okay, the problem with those that I'm sure that the one that has the 1 kilometer is not the little ones that you see that have the little onboard. No, it's got to have some sort of external.
Those are the non-amplified ones. If you want to use them indoors for 50 feet, that's fine. But if you want them to have any reasonable range, you need the amplified version, which is the plus version. They're about $3 or $4 each.
Yeah, can you put a link just so I don't?
Sure.
Yeah, I'd appreciate that. Okay, let's see. That's pretty much all I had.
Cool.
So anyway, that's where it's shaping up. Planning for 24. I really do. I'm going to be there. Just like Mike's going to be there in May, I'm going to be there in November. So that's where I'm going.
That's awesome.
Yeah.
I'm going to put some ideas, some thoughts in words, but to not steal the time, I propose we move on with the cues. So we have next, it's in the chat there, Cooper, then Brad, Paul, and I have a short thing, then Mike, and then Ray, not Roy. So Cooper.
Yes. All right. So tonight I'm going to be talking about a project that actually has quite a lot of similarities with Doug's there. Let me just pull up my presentation. So essentially what I have been working on is a controller, right? And I'm kind of asking myself, what's the key problem here? I can't finish my robots. I have presented in front of y'all many times, and I have never quite finished any of the robots that I've proposed, just for a myriad of reasons, some of them being, like cost and time with school and this and that. But one of the things I have noticed that has been somewhat consistent is that, and I'll talk about this later, because I come from a background working in FIRST robotics, I definitely have more intuitive understandings of how to kind of work in the robotic space through teleop first and then autonomous subroutines. And so I'll get to the point where I'll have a robot, but for the life of me, I don't have a controller. And a lot of the times what I ended up doing is just, I'll solder a big long wire from a potentiometer to the controller board for whatever little robot I've got, and I'll just stick with that for a little bit, and then I'll deal with the remote control stuff later. But I never do because it always scared me. But I've had some time now to kind of go and reflect and on kind of my portfolio and this and that. So I figure I need a project to start a new portfolio, something that's clean, something where everything actually gets done, and something where everything's actually documented. And I thought no better place to start than actually making a wireless receiver and remote. And so I will say that I have looked into a lot of the kind of ways that people usually do it. You always go on the internet and find inspiration. And I know a lot of robots actually still use like RC, like remote control, flight controller hardware, just because it's readily available and it's time tested. Something about it, I just don't know. I'm a Clem through and through. I just am obstinate not to use that. And so what I've come up with so far is a system using ESP Now, like Ray was, and Ray and Doug were talking about. And that's not exactly set. If somebody can convince me to use radio, by all means. But again, I'll get into that later. And so I wanted to start the project out by defining a design document. So actually, I have a document very similar to Doug's, where it's just, straight copied whatever this is. It's basically just saying, hey, the controller is meant to be this. This is my, my design statement, right? And then I've got some rules, general rules, like, a controller has to be a microprocessor, a radio antenna, a set of inputs, and an emergency stop button. That sort of stuff, general template stuff, so that if I have to come back to this in a week, a month, a year, I can look at this design document and I can say, okay, this is exactly what I need to be, working towards, and kind of keep that idea moving forward. And that's one of the big things that I had struggled with some of those robots is, I'd say, okay, well, I've got this great design, but I don't have any way to fund it. I'll go make money, I'll go work a job, do this, do that. And then I come back to it and I've documented just about none of it. So I am just completely lost. And then I start anew. And so right now, what the kind of general idea is that I want quantized versions of a robot, or a controller and receiver pair. So quantized just basically, and I could be using that word wrong, but basically it's just meaning that I want, a 1.0, a 2.0, a 3.0, and each one of those are standardized hardware and software and physical design specifications that I can essentially replicate as many times as I really want. So like if I lose the controller, if it gets destroyed, if I want to, and I'm not participating in any robot competition for this. I like to, in my pastime, and I really think that kind of getting this general hurdle out of the way might, again, lend me some more time to actually, and some more, effort to get some of the other bigger points of the robot done. But since I'm not competing towards, or since I'm not going towards competition, I'm not really, I don't have like a competition robot. I just have a bunch of robots, and I want this to be something that I can plug and play with any of my robots. And so kind of what I did here, and sorry, this is not my best presentation that I've ever made, but it serves its purpose. This is an MS Paint drawing of essentially what I envision so far 1.0 to be, where you've got your controller on the right, which is a mock-up I did about a year ago now of this kind of same project, of course, that I put down and now I'm picking back up. And I didn't have a modeled receiver, but you can see that receiver there. And I want those to communicate through some standardized communication protocol that, is on top of ESP now, that I published to some GitHub. And if I have to make another receiver, then it's there, I envision it talking to, I said a robot CPU in the diagram. It could just be some, even buffer between the kind of core of the robot and the receiver. But in some way, it interfaces with the rest of the robot through serial or UART or however you want to say it. And as per my design documentation, I have, communication with the robot. I've got wireless communication to the controller. I also have, power coming into the receiver, as well as a kill switch wire. I don't have it modeled on this controller, but I really am trying to prioritize safety in all this. And so I will have like a kill switch that is, something where, you press it down and it stays on. And I'm really just trying to figure out every single way that I can make that redundant. And one of those things is that, of course, the robot will receive that kill switch code, but also there will be a physical connection between the receiver and some sort of power supply, that just being, well, actually, I'll get into that. But that essentially what it does is it just takes in the battery and, supplies power to everything. And one of the big things that I was kind of avoiding using the flight stuff for, and I don't know enough about it, so maybe I'm wrong in this assumption, but, my kind of idea of that sort of thing is just, you've got your controller and then you've got a little PWM receiver or PPM receiver, and that's it. You can send signals, but you can't get any telemetry back. And I've been, trained through, again, first, that telemetry is, it is how I work. I use telemetry to ideate on robots and the code and this and that. And so it was really important to me. So I've kind of implemented that in here.
Cooper, I'm going to interrupt just a second. Just so you know, there are new modern RC controllers now that talk both ways.
Yeah, I'm sure. I'm just
letting you know, because you said you just saw it as a PWM controller on the robot, and in actuality now it can talk back and display things. Usually they use it to display stuff on a display. I'm just saying, but just so you know.
Okay. Yeah, totally. And like I said, I'm using ESP now for now. But assuming I find something better in the future, I'm all for it. In my design documentation, I was very particular about not specifying what communication protocol I use, because I really don't want to restrict myself when I'm kind of ideating on this controller. And why do this at all? Because obviously, right? Again, there are going to be other solutions, like using, the newer RC RC stuff and that and this. I have a bad history, and I'm continuing it through this, but old habits die hard, I suppose. Where I like to start at the ground floor of things and kind of build my knowledge by building it up. And so this is that essentially for me, is I'm actually starting to do wireless, communication and all that. So I'm learning so much about that. I understand, using the RC stuff and also ROS are the industry standards and typically what you'd see. But as I said, I don't have the time nor the crayons to teach myself it right now. And I just feel like this is, at the progress it's going, this is going to be done a lot sooner than I would be able to teach myself ROS anyways. And so I have a background with Iron Rain. I have background competing in first. And so I have this I understand it's skewed, but I have this kind of idea of how to make robots and how kind of, a teleoperator would interact with a robot and this and that. And so that's kind of the design kind of direction I'm taking, maybe. And this was going to be my big reveal, but of course, as I said, Doug and I had surprisingly similar ideas. So with this, I was going to say, okay, well, the power supply, I was thinking I could have the receiver, it would have a custom PCB, it would have, that's why I even, was looking at the MakerBot motherboard the other day, because I was trying to get ideas for, what connectors could I use? And so, I was thinking, I was just, as I was working on the control, I was just like, wait, I could standardize a power supply that, takes the voltage down from the battery and, takes in that control, or the kill switch line, and also has the switch, and handles this and that and this. And then I could also have a robot, or I could also have a motor driver, whatever. So I'm very much on the same page with you on that. I think that's really the way to go in terms of making kind of the, I don't know, that's where I think that a workflow of, making robots ideating very quickly would go. Like I said on this, it's I'm basically creating a modular control hub, or I aim to eventually, just where I know Rev is very good, but all in all, it's rather expensive, you know. So,
I'd like to do stuff from scratch. Hey, can I ask a question, Cooper?
yeah, totally.
Just so, do you have like kind of a time boxed target in mind for any bit of this?
So, a little bit. I was actually going to maybe use DPRG in some ways as a time box where I would set, goals that I could present to y'all and kind of show progress as I move along. I've also started using Notion as well as my Google Calendar. So I'm really trying to focus on, using those new tools that I'm trying to integrate into kind of the way I do things in my life to also do this.
Okay. Yeah, because I think I just have a sense that I know it's helped me to have. I mean, you get this long term. Like when I first joined the club, I thought, okay, 6 months, I'll knock this out, then I'll move on to something else. And okay, 3 years later, I did the contest. I thought I could do in 6 months, but it sure helped to have a kind of a
time scale,
quantified target, and then if you subdivide time boxes, then it forces you to make decisions, and they don't have to be forever, decisions. But if they get you to the next time box, then you can feel better about getting something done. And
yeah, I totally agree. Actually, the other day I was really struggling because a little quirk in ESP now is that it's really tough to send dynamically sized data over because of how it all works. You send over your data and you can see how large the data is on the receiver, but if you've got a struct that has a string in it, because those structs are compiled to be the size they are, right, then it turns out that dynamically assigning that kind of size for the string isn't possible. And so I was really just trying to scrape my head for any solution that I could, because I really wanted to keep the idea of, because in the future I'm going to have I'm going to make a class for this sort of receiver that the the robot can interface with it with, and I really want I want to be able to put as many telemetry data items as I want to until it starts to bog down the network. I just kind of want this to be so plug and play and configurable. And I was really driving myself insane trying to figure this out. And a friend actually was just like, well, why don't you just limit it for now and move on, figure that out later. And I was like, oh my goodness, of course. Yeah. And I did finally figure out a solution that I think works. And actually I have part of that on the screen here. So in my main repo, I've got this all on GitHub, though it's not public just quite yet. On my main repo, I'm trying to keep a very consistent timeline of features where, a 1.0 controller, or as I'm demonstrating here, just a very simple, sends over, a single byte of how fast the motor should go. That was a branch off from my main branch on the GitHub. So I can keep the, the main kind of line clean, and I can, also have all of those different branches documented. But I did a basic motor test. It works actually. In there is, you can see in the back there, that is that Cytron DC motor controller that I was talking about. And again, it's really nice. The packaging was super nice, whole 9 yards. It's got a lot of features that I just didn't even think of that are super oh my God, why didn't I think of that? In any case, so that was very promising having that happen. And just recently, actually, I did a throughput test because I was really worried about the telemetry and, what size should my packets be so I can get the most out of the network and this and that. And this is actually wrong. I think I can have just about any amount of dynamically assignable telemetry of data points. but it's about 40 bits before it starts to really bog down the network, or before it really starts to get complicated in assigning the packets so I can then send them over. In any case, that's what I've been working on my other screen here. But even past this, I've started to use UART or Serial. Right here, I've actually got a dummy robot CPU, so to speak, that is serving dummy values for telemetry data names and telemetry data to my receiver board here, and. So far, I've got the whole initialization process working. It automatically reconnects. I've got all these actions associated, like if it disconnects, like what do you do? And so, yeah, I'm really happy with the progress so far. And I should have more progress. I should hopefully have something to physically show next time I'm here. Maybe I'll even make a demo of some sort. But in any case, that's just about the end of what I wanted to show y'all. I had a couple questions for the general group that I was maybe curious if y'all might have some inputs on. One of the largest ones that I've really been thinking about and I have not been able to figure out a good answer for is, where does debouncing button inputs happen? Because I could debounce on the controller, but then if I send that signal and the packet gets lost, then that button press is gone. Because I'm really looking at using the buttons more for doing teleoperation, like autonomous subroutines.
A million ways to do that.
Okay.
So, yeah, the most basic, the most straightforward is even an RC time constant for a switch for debouncing. So where it doesn't take any processing at all, but it has to be tuned. And then you can do, like if you're doing multitasking on your controller, you can have the switch, interrupt and then go back and check its state, every whatever your time period is, 20 milliseconds, whatever, and do it that way. So you can do it a bunch of different ways.
Just out of curiosity, though, where would you recommend doing it? Because that's kind of where I'm getting at, is that, I could do it on the controller side, but if those packets get lost, then that sucks. And if I could do it on the receiver, but, then, I don't know. I really don't know if the receiver has enough overhead for that. I don't know. I mean, I haven't really done any loop time testing to figure out, where's the bottleneck and all this, but I think there is a bottleneck. And I was thinking, I could do, a non-blocking version, some, non-blocking finite state machine sort of thing that actually debounces it, make that like a class and this and that. But I just don't know if I should do it there because, even with TCs and that sort of thing, I don't know if I'm going to have the overhead for like PID loops, and time is key on that sort of thing. So, yeah.
First on, from an architectural point of view, I heard earlier on that you want to have a kind of a general purpose controller that you can reuse on a lot of different things.
Yeah, that's true.
So think about it. If your controller is going to require any of its clients to implement debounce, and if you're going to have that kind of architectural partitioning, you've now defined an architecture that's going to impose a lot of requirements for every single thing the controller is going to use.
Yeah, fair enough. Okay, so I'll do it on the receiver.
Logic alone, I would suggest make the controller as self-contained and flexible and reliable as possible, and then also on your communication interface. I mean, hopefully you mentioned dropping packets, but hopefully you're going to do a similar thing where you can make the communication bus as reliable as possible.
Yeah, so I agree with you. Actually, I suppose you're right. Then I should probably do it either on the controller or this receiver. I'll just see, if so. It's just tough. Again, I'm very new to all this Wi-Fi stuff, and so I did some speed tests and packet tests to see how many were dropped, and my numbers didn't quite add up. So I need to take a second stab at it and just see, if I'm really losing that many packets, if it's something to worry about. I agree. And just see, what I can do to make it more reliable. I agree. I was actually thinking, for redundancy sake, I might have an ESP32, with an external, antenna, but I might also have a secondary, kind of typical RC radio that sends over that kill switch signal, right? Which is literally just set, one, bit higher, send, that it's been, triggered, and just have, kind of two antennas, and one of them's literally just for, redundancy on the kill switch code, because I really think that is kind of the most important. That's the most important thing to have be received.
Hey Cooper, I missed the architecture bit. I got in late, but I would recommend that you do debounce as early as possible.
Okay.
Like before it gets to network. It shouldn't really depend on network kind of stuff, and you're just going to be seeing a lot of noise over the network if you don't do it ahead of time.
That's true. Yeah. I just. Okay. Yeah. I'll definitely. I'll look at that then. I'll look at doing it on the controller. I think the controller is probably going to have more overhead to actually do stuff like that, so that might be the better option.
Any basic signal processing you should do before it goes on the network, if you possibly can.
Okay, yeah, I'll do that then, and I'll also do the potentiometer smoothing on the controller then. So on here I've got, if there's any other Wi-Fi protocols other than ESP now, I mean, again, I can extend that to RC stuff. But I really do like Wi-Fi, just for the idea that, there are general purpose, kind of range extenders that I could use, that I could just, off the shelf sort of stuff. And also too, back in FTC, we actually had this tool where we could, log onto a computer and kind of middleman, where we could interface with the robot directly and see telemetry data, but we were also kind of it was basically just like a web client sort of thing. I don't know. I thought that was really cool, and I just don't know if you could do that with the RC stuff. I don't know if you can really do it with ESP now. I might have to make like a client, like some sort of Python scripts or whatever to actually take apart those ESP Now packets, because I know they've got a bunch of extra stuff in them. But that extra stuff is actually is for reliability's sake. So I do think that I should keep all that. Just I don't know. But is there any other options out there that I'm not really thinking of for that sort of thing?
Hey Cooper, it's nice to see you again. I think we met at the judging of the first contest down south of Dallas.
Yeah.
And I've got a couple of thoughts here. One sort of lower level, sort of approach perspective, and another kind of higher level, what are we doing and why are we doing it kind of level. So the approach perspective, you talked about Ross being a big lift and not having time or the stuff to do it. I just want to make a counter observation, which is that Ross really gives you a lot of the stuff that you want. So, for example, a joystick controller, you just buy an Xbox 360 joystick controller and start up a couple of nodes as examples on how to do that. And to your point about liking telemetry and teleop controls to go, that's all kind of seamless. So I guess I'd offer to you that you maybe don't want to discard that so quickly, and I'd be happy to help you offline get going on that stuff if you'd like.
Thank you.
the second, and you got my email, so feel free to ping me. The second is sort of higher level, and you talked about how do you wanting to know when you're finished and how far you should go and what it's going to be, and really in some ways you were talking about requirements, and there's a level of engineering design, and so okay, I'm going to switch into professional engineer mode here. Prior to implementation should come requirements, and then the architecture should be one part of an answer to requirements, and then the implementation details should be another part of an answer to requirements. And requirements come in two flavors, functional requirements and non-functional requirements. And non-functional requirements are superior to functional requirements. And so non-functional requirements are the properties of something. So it is this, it shall be this, rather than it shall do this. And they're more important than functional requirements in that they determine why you would buy something. So a customer will buy a car for its non-functional requirements, such as it shall be powerful or it shall be comfortable. Those are things that it is. Those are properties that it has. They're not something that it does.
Yeah.
As opposed to the subservient functional requirements that serve the non-functional requirements, such as the seats shall have buttons that will be convenient to move the seat forward and backwards, and it shall have a 7.3 liter gasoline engine. Those are not things that it properties that it has, they're things that it does. It shall achieve 120 miles an hour in 60 seconds. So I feel like in part your presentation was focused on like, I'd like it to be teleop, but I don't want the teleop to be analog. Well, the question you need to ask is why? What are the real requirements here that you're really getting at? And so let's see if you'll unshare. I've got just unfortunately, I usually do a great job of documenting my requirements for my project, but unfortunately I didn't do that for Mobot so good, but hopefully you'll get the idea if I can sort of like show a couple. Let's see.
Should I stop sharing or?
Yeah.
Should I stop sharing or?
Yeah, please.
Okay. Yeah, sorry. While you pull that up, just to kind of come back to that first question, that first response, sorry. I totally agree. I don't want to throw away ROS. I think that it is a long-term goal, and I agree totally that it is everything that this project sets out to be. Partially, the only reason I'm doing it this way, kind of circumnavigating ROS, is partially because the hardware requirements for ROS, the power is rather high, and I think for right now I just kind of want to stay in the domain of microprocessors. And also, I really do hope to publish these quantized versions 1.0, 2.0 to the public, such that somebody else, because all of the design specifications or all the design documents are public and open source, I really hope that it could maybe help someone else in my position as an intermediate I'm not a novice necessarily, but I'm also not very, good at it. I'm nowhere close to being an expert. I'm an intermediate, and I'm not ready necessarily to take the step into ROS, but I really want something that is robust and kind of has that that sort of polished feel to it. And I think that making it would teach me a lot, and it already has, but totally I agree with you, ROS. I need to learn ROS. Yeah, 1,000,000%.
I think it was partly that you're talking about instrumentation, and ROS has a lot of that.
Yeah.
And also, it's like you're young enough where learning ROS now will go a long way, and not be so difficult to pick up that some of us have challenges with. So
those of us without hair, okay.
Hey, I haven't done it either. So just go for it. Not that I'm saying it's the right thing for this project. And again, I didn't really miss you. I didn't get all your setup there. But the more sort of ongoing experimental approach that we did in FTC is also a thing that is great to continue doing with. And I don't have any recommendations for you. I don't know enough. We've done some stuff on the ESP platform, but not with the kind of instrumentation that we have in FTC, with FTC dashboard and stuff like that. And you know how very useful that stuff is, right?
Yeah.
Having good instrumentation. So if you want that, you may have to invest a little bit in like rolling your own. I don't think you need to, again, take small incremental steps. Visualization is fantastic. It really helps you out. It almost always pays off to do it, to set it up. And so get as much instrumentation as you need for your project, but also be thinking about moving or learning ROS, if not for this project, then for other stuff going down the road.
Yeah, and to address the technical obstacle that you mentioned, power. If you didn't quantify power limitations, but you can run it on a Raspberry Pi, so that's not a lot of power there.
It just kills me. I've got a 3B plus, and I wasn't able to get it running for whatever reason.
Okay. But the way I'm speaking here as someone who's done systems engineering and systems requirements, and I start off with use cases. I've also started with user stories, which are a good way to start with requirements. User stories tell the story of what a user wants, how they go about their lives, and what value they want from the system. Use cases describe things that you want the system to do. So, for example, to reset or restart the autonomy layer or motion control layer, and the system resumes operation, or to stop the autonomy layer and the robot stops in a safe state, or to analyze logs and bags from runs. So, you can fairly easily come up with one-liners that are the things that you want to do. Obviously, one of your use cases is teleoperate the robot. So you just put down that, and that's a measure of whether you've achieved success in providing that use case. And then requirements are always written as the system shall do X, except for non-functional requirements. So these are the functional requirements. It shall transport packets between this layer and that, and drop packets of fail checks. These are all the things that the system should do. The things that the system should be, or its properties, shall have modular design, or I think you mentioned some other, I heard a couple of other non-functional requirements, but they're worth splitting out because non-functional requirements primarily influence architecture. Architecture is mainly driven by trying to meet the non-functional requirements, and Doug mentioned a bunch of non-functional requirements sort of implicit in his presentation of design ideas. For example, he had modular connectors with identical wiring. Well, you take a step back from that and you say, what are you really trying to achieve? Why are you requiring that? And you'll come up with a statement about something like the ability to easily exchange cables between different connectors, perhaps. I'm putting words into Doug's mouth here, but you get the idea of pulling up to the highest level, what should its properties be, and then from there, what should it do, and then using use cases as, these are the things, the situations that it needs to do particular things in, as a way of specifying, what it should end up being, and what you end up with at the end of all that is, and I'm going to switch to a different project here.
While you do that, just to throw in there, I'm really grateful that you're showing me all this, because I started, there's a tool that I like using, Obsidian. It's like a note-taking app. And actually, I put on the GitHub repo, I put an Obsidian doc that is very similar to what you're talking about, but it's a bunch of the stuff you're talking about shoved into kind of one list, and it's not as elegant as putting it into functional, non-functional, because I've gotten written down here, like the physical controller. A controller is defined by a microprocessor flashed with the controller firmware, a collection of sensors, a kill switch, and some sort of status output. And that is, I guess that would be a non-functional?
So if you want to run some ideas by me offline, I'm happy to look at them. Requirements should be expressed in the form of the X shall do something, if it's a functional requirement. So I'm just showing some examples of an IoT device set of requirements just to show what the end state ends up being. So it's expressed as the IoT device shall measure water flow. And then at the end of the day, you're talking about how do you know when you're done, or how far along you're doing. You can give it as a status of delivered, or delivered 5-minute updates, or Wi-Fi only delivered. You can close the loop on how well you did at delivering the functional requirements. And then the non-functional requirements, you can also mark in the same way. For example, non-functional would be IoT device shall operate in indoor unheated environment, min temperature 0, max 40. So that's a property of the system. So I think it's worth splitting these things out into its properties and the things it shall do, because it helps you think about the thing. So anyway, I'll get off my hobby horse there, but happy to. I worked in requirements for a long time, and it's something I feel very passionate about, and it helps orient you about what are you trying to do, and how do you, and what's it going to end up looking like.
Yeah, 1,000,000%. So to wrap up my my thing, because it is I'm past my time here. Just kind of a quick lightning round here. Other than buttons, joysticks, linear, rotary potentiometers, maybe an accelerometer, so you could do stupid gyro, the robot moves when you rotate it, that sort of stuff. And an e-stop. Are there any other sensors on the controller that y'all think I might have? And again, the kind of central core of the project won't have any of this. This is just so I can start to get along moving with a 1.0 sensor list, so I can start to order things.
good start.
That's a good start. Okay. I haven't thought of anything else. I'm sure there's a couple other sensors that I could throw on there that might be fun. I mean, what's a project without a fun factor? Name ideas? I'll skip that. I'll figure out a name eventually, unless one of y'all has a really good idea. But I don't know. And any other thoughts? I think that's been expressly covered. So
Iron Rain was here today, and they did a naming session, and it was all over the place. So you don't want my help with that.
Hey, it's better than I used to. When I was on Iron Rain, I was the coder for 2 years essentially, and I got to name the robots in code, and they were horrible names, horrible names. I mean, it was like Stuff and Things Robot. It was just.
I concur. They were horrible.
So I just need.
And that happened today. I suggested Skyhook for a grappling hook mechanism, and they went in and started calling everything Kareem Abdul-Jabbar. So,
well,
go figure.
Thank y'all, all of y'all. I'm gonna have to come back tomorrow and take some notes on the recording there. So, but I mean, so much thank you, because I mean that was a lot, and hopefully I'll have some more kind of physical stuff to present next time. So, thank you.
Cool. Looking good. Thanks, Cooper. I think next in line we had Brad, then Paul, then I had something. We had Mike, but I think he left momentarily, and then Ray.
So I'm not sure how to do this. Do I hit present now? I don't have anything paper. I was just going to show you.
Oh, that's fine.
Around the room. Okay.
Yeah.
Okay. So back in 1998, back when I was in DPRG before, we had an RBNO where we went to a guy that had a mill and milled out aluminum for a robot. So this was the original Tom Servo, and he used a stepper motor that was underpowered, and he was overweight, and so I was able to do quick trip, barely, and very, very slow. So the whole thing I'm doing now, and I'm, talking about having goals and getting stopped and started. I've been working on this ever since, and I've actually never gotten a robot to do anything more than go across the floor and come back. And so the mission now is actually to try to do some of the DPRG competitions, starting with Quick Trip again, only actually having something that will run this time. And then, maybe, 4 corners or the 5-1 and maybe 6 can at some point. But all the competition rules have changed. So I'm going back through. But where I was back in 2015 was trying to get something moving. I don't know if you can see the mechanical design in the background, but that's the Fusion. It started off in Inventor, but it's now an Infusion, and it's based off a Parallax Stingray platform. I don't know if you can see that, but it's basically got HCSR04 sonar modules, which are working. I've got one running here on the desktop. And so all my sensors are basically working. I'm prototyping in an Arduino Uno just to get the sensors checked out and working. I've got the sonars working. I've got the IRs working. I've got switch and switch debounce working, but no bumper designed yet. I still need to design the bumper. And then this is the motor driver, which is the RoboClaw for right now. It's running off an RC, input. So I tested out the platform this time because after failing so miserably at Quick Trip before, I kind of figured that getting the base to run and run reliably and fast enough to actually make it across the floor and back was kind of important. So I did that. And then after that, I've downloaded the LMX code from the DPRG library, and I've got that running. I don't know if you can see the benchmark test running on that. This guy is the Mega 2560 Arduino. The Uno R3 really wouldn't run it. It didn't have enough memory, and so the task, this is a multitasker, and so basically building up the task table and running, that number of tasks ate the Uno. It overran its task list, and so it runs fine on the 2560. So what this is right now, this is a subsumption architecture, very similar to what Rodney Brooks did and DPA. David Anderson copied. It's also in the robot programming book that a lot of you are probably familiar with. I think Jones wrote that one.
Mobile robots.
What now?
Mobile robots.
Yeah, that's the first one. So the original book that I read on this was this one. I don't know if you can see that.
Yeah, that's mobile robots.
Yeah. So the new, it's kind of basically a rewrite of those same ideas called, and it's in robot programming by some of the same people. And it goes into a little bit more detail in, not in Lisp like some of the original, or assembly like some of the original examples were from those books. So, it's a little bit more helpful. So that's kind of the base of where I am right now. I've got pretty much all the sensor code working. I wanted to use Arduinos for the reflexive stuff, the low-level stuff, basically because you can get libraries and prototype very quickly before moving on to something a little bit more permanent. So that's the idea right now. I have most of the behaviors written, but I've kind of got to integrate everything before I can actually test it on a real platform.
Cool. Very cool. I'd like to see, I've used that, David Anderson's code there. It's is it LMX? Yeah. Nice piece of software.
Yeah, it seems to work. This one's been running for about a week, and so it doesn't seem to have any leaks in it or anything. This version of it. Originally, when I was running into trouble on the Uno, I ripped everything out that's not AVR related. Yeah. So on the the Motorola, and I think there was an ARM piece in there. I ripped all that out, but it turned out just to be that it was running out of memory.
Yeah. I want to say that that somewhere, I don't know if it's on our GitHub, but there is a version that'll run on a Nucleo too. Yeah,
I haven't seen that. I have.
If you can, you can ask Dave. I'm sure he would be willing to share.
Yeah, I have a couple of those laying around somewhere here. So at some point, that's going to be worth it. I want to do all the reflexive stuff. The low level, escape, avoid kind of behaviors with an Arduino, and then do an RPi with ROS maybe when I get to doing some visual stuff or some LiDAR stuff that's going to take more horsepower. Yeah, that would be an upper level behavior thing, not the lower level reflexive stuff, which is what I'm working on now.
Cool. I like that design that you've got in the background on the screen. It looks like a cool robot.
Yeah, that's it's actually the design. The chassis design was actually a kit put out by Parallax.
Okay.
I'm thinking in 2012. They don't make it anymore, but it's a really simple design. It's got some issues. So if you look at the context rules right now for the length of the robot, given how that back part sticks out, that's an omni wheel in the back. It barely, if you put a gripper on the front, you're kind of limited on what you can do with it. So there's some issues with this. It would be better to have really a round, more of a round without. Let's see if I can actually show this thing. So if you look at this thing, I don't know if you can. I'm gonna tear it.
So it's kind of like a diamond, right?
Yeah, it's got like a tail on it.
Okay, so like a shield, like a badge, like a shield.
Yeah, yeah. So at the Omni wheel, the coaster basically on the back sticks out a little bit.
Mm-hmm.
So it's it's a lot longer than it is wide.
How wide? How long is it?
Well, so it's about. Well, that's a good question. I can't remember.
Because I believe that most of the contests allow 18 by 18, if I remember right.
Yeah, but the problem is, it's about 15 inches before I get the bumper on.
Yeah.
But then with a gripper, which you want for
6 cans.
Yeah. Then you're kind of limited on what you can do. You kind of have to stow it. Which
Okay.
is more complexity than I really want to deal with.
If you get that far, let me before you go nuts. Let me know. We might adjust the size to allow you to do it. Okay.
Yeah, I'm glad you brought that up. There's a couple other questions I had on that. Now, this one, the weight on this one's not a problem, but if I go back to trying to get this guy working again, that
holy crap! How thick is that? Is that 3/8 of an inch?
Looks like it's
1/4-inch aluminum plate.
Is that for a man portable robot?
That's right. Yeah.
That's what he had laying around in the garage when we were doing RB&O one day.
Wow.
So that's what became the robot.
That's
Wow.
But if I total all the weight up on that without any, the processor's out of it. It was an old 68340 on the original. So I don't want to deal with that anymore. But when I total all this up, I'm pushing weight limit or over the weight limit for some of those contests.
What's the weight limits that you're pushing over?
So that's the thing is that if you read through the rules, like the 4-quarter, the quick trip, the 5-spot, and the 6-can, all have different weight limits. They have basically the same
size,
shape, and height.
Yeah.
But some of them are at 15 pounds, some of them are at 20 pounds, some of them are at 30 pounds. Is that intentional, or was that?
No, it's probably just evolution. So how much would that robot weigh? Would it do
That's a good question. The pieces right now, I know the pieces weigh about 18 pounds the way it is right now without a gripper and without battery. And so I was thinking of using for this one a life battery. It's a little hefty, but a little bit better than what I had in it originally.
I'm sorry, I missed the exact what you said just then. I'm sorry, Brad. How much did you say?
It's about 18 pounds the way it sits right now.
You mean just the structure?
The structure with the motors and
wheels.
And the estimate of what the battery is going to be.
Again, if you run up against the limit and you really want to compete with that robot, let me know, and we'll look at the rules. I mean, obviously, the main reason the weight limit is there is to prevent either damage to the course itself or to the environment that we're running in. So, like if you're doing something like quick trip, and your robot can be heavier than, we can adjust. If that one's the one that's catching you, we can adjust that upward.
Yeah.
But if it, six can weight probably is whatever it is probably a pretty good limit because, well, not in 6-can, but we just got a brand new arena. Scott Gibson designed us a really nice 6-can arena.
Okay.
And that, for sure, the one that I was going to say that I'm sure that we would try to keep the same is the one that's can soccer, because there you're running up against another robot, and there are, you could smack somebody's because could smack somebody up. But we might be able to give an inch or two on the size. You know what I'm saying? So you just so before you hit a limit, I mean, if you just say like, well, either I have to have 20 inches or I've got to redesign this robot from the ground up and put let us know.
I can make it work no matter what it is. I just was curious when I saw the different weights.
Yeah, so I'm trying to. Well, every once in a while, a certain team that's not copper suggests that they're going to run in our competition, and we bend over backwards, to fit them in, and then they fudge out on us. So I don't know. That's probably might be some of the reasons you see some of those variations, especially at 30 pounds. I'm thinking what.
I don't have a problem with 30.
I thought it was to make less than a 1/4 inch dent in whatever flooring material was, like it fell off the table.
Yeah, I don't know. I mean, you could see. So what I could do is basically go to like an ABS or if I needed to drop weight and just use the.
No, I don't know. I don't think the aluminum should be that bad, really. It's just you're just using a really super thick plate. That's all.
Yeah, you could probably use 1/8 inch. Or less.
Yeah,
easily.
That would be plenty strong enough.
Yeah.
And even the struts are not like that was the original processor interface, and that's not light aluminum either.
Okay. It'd be fun to see it, though. It looks like a really nice robot.
Well, it doesn't run, so
no, that's not good.
It's going to have to get to the moving stage at some point. So I think that's all I've got. It's just basically, making progress. Hopefully, I'll get something moving on its own without the RC control here.
Yeah.
Too long.
Okay, sounds good.
Looking cool. Can't wait to see the next. All right, so I think next we had Paul, and then I had a quick something, then Mike, if he's back, and Ray. Paul, are you ready to go?
I'm back.
All right. Paul, you're muted, I think. You've been muted.
Thank you. Two things, both short. The first is to report. So last week I demoed ROS 1 running in a Docker container, running the robot under the gazebo simulator and getting it to drive. And I just wanted to report, and the purpose of that was to allow me to upgrade my laptop from Ubuntu 20.04, which is tied to the last release of ROS 1, to 22.04. Just wanted to report that I did upgrade my laptop, and the Docker container still runs. I can still run Gazebo and Aviz and watch the robot move, get it to drive using ROS 1 software on my laptop that's running 22.04 now. The second thing is Doug offered a very interesting presentation last week on something he had found, the cheapest possible ROS 2 robot, and he said that it was ROS2, but it used a microcontroller, and he wasn't really sure what that meant. And so I, being interested in ROS, all kinds of ROS stuff, I dug into it and found what it means, which is what I'm going to present now. So the long and short of it is that this ROS, micro ROS2 is actually a thing that's like ROS serial in ROS1, which I worked on for a while, which is it's a way to get something on a microcontroller to be able to act in the ROS environment, so to publish messages to the ROS stack on, for example, encoder counts, or to accept commands like throttle and steering commands. And microROS is that kind of thing. And the way it works is you would, and Doug, you talked about them having a laptop and you didn't know if that was really needed in the environment. The answer is it is. The micro ROS fits inside of a full-blown ROS2 stack that runs on a laptop and runs all the good ROS stuff. And it has a ROS2 agent that can talk over Ethernet or serial or Wi-Fi to a micro DDS agent. And then they use the ROS middleware interface, which they leverage from the ROS2 environment to provide the ROS2 API in C that you can then write code on top of inside of your microcontroller environment. So inside of your ESP32, you might be running POSIX, you might be running, well, you wouldn't be running POSIX, but you might be running FreeRTOS, or you might be running just just the Arduino kind of ROS environment for ESP32, and then on top of that, you'd run this client that provides a message interface which can be surfaced to allow code up on top on your microcontroller to publish sensor readings or diagnostics or accept service requests, or it lets code components on your microcontroller act as nodes, as if they were nodes in the ROS2 stack, without requiring all of the infrastructure and hookups that the ROS2 nodes require, because all of those are handled by the ROS2 agent and transferred over the link to this micro DDS client. So does that make sense for what this micro ROS architecture is?
It makes sense, but let me ask this basic question. If you're a complete novice in ROS, is this a reasonable place to start or not?
I don't know how to answer that. That's sort of like asking, is ROS a reasonable place to start if you're a novice in ROS? I think these days ROS2 is probably better than ROS1, a better choice.
Voice is trash.
I don't know if that's you or somebody.
Seems to be
Yeah. Okay, Harold's muted.
Okay,
I just
I'm
muted
back.
him.
Okay. ROS is a very powerful thing, and I'm happy to coach anyone on it. I think it can really offer a lot. You do want to be someone young like Cooper, or someone who knows Linux, if you don't know Linux at all, well, actually, you got ROS 2 on Windows now, and I was reading up about that. So, maybe it's okay. But anyway, it's neat stuff. It comes with a lot of really powerful tools. It's a big system, but you can do a lot with it. And if you don't use it, you have to reinvent all of those things like joystick controllers and telemetry and logging and playback of logs and all of that stuff that you just need. So that's I don't have an answer on whether it's right for you.
Well, I'm just saying, if one is going to stick their foot into the ROS environment, would this be an appropriate one?
I don't think micro ROS really figures in that larger decision. You either do it or you do something different. Like, I didn't know about micro ROS, so I end up implementing my own serial, multi-channel serial protocol. Well, I cobbled on cobs, but point is, you roll your own interface between like RPi and an ESP32 or Arduino, whatever your microcontroller is. You either do that or you use this as a tool. But the first question is, are you even going to use ROS? You got to make that decision first.
Well, Paul, I guess the question I think David is asking is, okay, this is a series of at least 3 articles. I don't know if you put a 4th one.
Yeah, I've read it.
Yeah, and the question I think he's asking is, okay, I'm kind of interested in ROS. Would these 3 articles, because the cost he's quoting of $60 is pretty cheap, is this a good 3 articles to read and follow to get an introduction into ROS 2?
I don't think that the articles really give you an introduction to ROS 2. They've got a GitHub repo that has the code for the microcontroller, and there's standard ROS 2 stuff that will let you do a joystick and publish speed and turn messages from a joystick to the environment of which this robot would be a part. It's not really an introduction. It doesn't go into any of the ROS 2 concepts. It doesn't really even explain how the micro ROS software works. They just really say, download it, here's the repo, program it, and if you've built this robot, then it'll run. The 3 articles are really about building the robot hardware, not about how you use ROS.
Okay, well, thank you. That gives me a good feel.
Yeah, if you're into YouTube, there is a good series on like starting out with ROS on implementing a basic robot from Articulated Robotics, I think is the guy on YouTube, and he goes through ROS 2.0, kind of from the ground up. If kind of give you a feel for whether it's the thing you want to do or not. But from a controller point of view, I don't know that I would do anything out of the ordinary if I were actually trying to learn it. You got enough to deal with learning ROS and Linux and Ubuntu, on its own, that, most people are doing that with a Raspberry Pi on Ubuntu. I think I'd go the path of least resistance.
Yeah, I think from the point of view of these 3 articles, you could equally well put your own code on the ESP32, like Arduino, code that would be run under Arduino, build a subsumption stack, and do all the stuff that you would normally do. There's nothing intrinsically ROS-ish about the robot described in these 3 articles.
Well, so what you're saying is that he's not really doing anything that's really that ROS-ish.
No.
Okay. Thank you.
If you're going to take it off, and
It's still a kind of toe hold, perhaps.
Yeah, yeah. I mean, it's a nice, cheap robot, and some people like to build robots, and some people like to play with their electronics, and others are better with their software, and everyone tends to gravitate towards what they're better at.
So, but what you're saying is that for a physical robot, mechanically, electrically, it's pretty good, but pick your own poison for programming.
Yes, except I'm not offering a judgment on whether it's pretty good or not. I defer to Doug, who's built far more robots than I have. I tend to buy them because I suck at mechanics. I can't get two holes drilled through this two pieces of metal to line up, and
That's what makes it fun, though.
Fair enough. Thank you. Appreciate your inputs.
Okay, cool. Okay, Paul, so was that it for your thoughts?
yeah, MicroROS and Docker containers working on Ubuntu 22.04.
Awesome. Okay, good deal. Okay, that means next it's me, then Mike, then Ray. Mine will be short. So they're marginally robot-y related or mechatronics or I don't know, something. So the first one is this link came up from a friend during the week, and I'll put it into the chat. But basically, I won't run the whole video, but somebody made this kind of spherical.
I remember those.
Oh my goodness! As if it was only yesterday, Kareem. Is this?
They've been around for a while.
Yeah.
Okay, that was new to me. So
Yeah, it's cool though. Yeah.
Old dog, new tricks, I guess. So
An active ball joint.
yeah, it's pretty wild. And they at some point in here they show it loaded down with a few kilograms of something on a whatever.
So they're actually transmitting power through it then?
Oh yeah.
Oh, wow.
Yep.
Hmm.
Is it 3D printed?
Oh, I'm sure it's 3D printed, but here you got a 300 gram on 300 millimeter, and you can see as it rotates around that it hits a kind of a rough patch in the gearing because it has a few jumps and spots. But
Looks like a good joint for a dog robot. Yeah.
Yeah, it's 300 grams, not a whole lot of weight though. God,
yeah, versatile. It doesn't strike me as something that it's got a lot of robustness to it.
yeah.
But interesting nonetheless.
Hmm.
So anyhow, so that was a good find, interesting find. Then the other thing is, I bought some of these. I haven't tried them yet, but has anybody seen these solder seal butt connectors?
Yeah, seen them, used a few of them. They do work pretty good.
Yeah. Okay.
Same here. I've used them. I haven't ever done them on anything critical, but they work.
All right.
You gotta put a lot of heat on them though to make sure you get good solder flow.
Do you?
They're not a pencil solder gun type joint.
Or like
They're more like a
type soldering iron.
well, I don't know about that, but more like a heat gun.
A good heat gun, or even a torch, little.
Yeah, a little propane torch type thing. But I don't know how the plastic would hold up for that. But with a heat gun, and I'm talking about a 1200 watt heat gun, and they do. The plastic doesn't get destroyed or anything, and the solder does thing. I tried it with a 300 watt heat shrink heat gun, and that was not enough. So, and again, with a soldering iron, it's not going to be really. It's not the right way to do it if you're going to use a soldering iron. But a 12 to 15 115 watt.
Like one of these, a real paint stripper kind of.
Yeah, one of those. You see, go slide them over. I'll show you. Let's see what he's got on there.
Yep.
That one's got a check. What's the next one over? The one that you.
Lighter.
So I would say that means no flame.
How about a blowtorch?
Yeah.
How about oxyacetylene? Okay.
Burn it.
But if you use that gun like that, it works great.
All right.
Can you put that link in the chat?
Yep, I'm going to put it in.
And you can get really tiny ones. There are available. I don't know the price, but they're available from really small, like the size we might be interested in. To the size of. Well,
this shows 26 to 24 gauge right here in the kit that I got.
Yeah. So that's what I'm saying. They can handle reasonably sized wire and not just big stuff that you wouldn't normally run into in a robot.
Not just the 10 to 12 gauge that's
right.
For a Godzilla burp or something.
Yeah. In fact, on one of those, I don't know if I'd trust it because that means they're probably sending a lot of current through it. The little ones, they're not, but
if the resistance is high, it might be enough to melt the solder.
Yeah. A good
we'll see it.
battery and an ESC you might need that.
Okay.
For a very short time.
Yeah.
Well, if I get a chance, I'll make a video or do a live demo or something, but I thought at least I have something to show for tonight, but that's it. That's it for me. That means next we have Mike and then Ray, then open mic.
All right. Well, I have my robot here, chassis, I made with carbon fiber tubes to keep it strong and light. And this is where the battery mounts, right here. And then I put my wheels on, and on the top side, I'm building it, debugging it right now with this prototype boards, and then this thing sticking up the top is going to be is a carbon fiber rod that I'm going to mount my camera and sensors on, and I haven't cut it to length yet. Right now, it's just nice to hold on to, and so I was going to give it a show and tell and put the battery in it, and I just coded. I was going to go into here. Like this is the controller board, so it has a Pico, Raspberry Pico 0 here. Just a really small board, and then I have a level converter because I found out that the Pololu motors, their encoders require 5 volts. They won't work at 3.3.
I don't know about that. Well, I think I've run them at 3 volts.
The spec says 3.5 minimum.
Yeah, well, okay, maybe. I don't know. I think I've run them on a 3.3 though. Well, could be. Maybe I got lucky.
You had these 6 Sigma ones.
Yeah.
And so I said, I'll just put a little level translator, which is real nice when you have to go between different levels. So I got 5 volts on one side and 3.3 on the other side, and it's a bi-directional level translator. So it's real easy. Then I got 2 motor drivers, and then these are the wires going to the motors. And on the bottom side, I'm going to be mounting the casters, the GoPros, not the GoPros, but the Go Builders. They're pods on here, and they'll act as casters and act as odometry.
Nice.
So that's going to be my next thing is to make in 3D print something to hold the Go Builder pod.
I think they're called odometry pods.
Odometry pod, yeah.
Yeah.
and get them on the top and the bottom, one for the X direction, one for the Y direction. And so it'll be pretty good. So right now, so the weird thing is, I didn't really want to, but it took shape of a Roomba. It's round.
Yeah. Well, it's a good shape.
It's a functional shape, you know.
Yeah,
Are those carbon tubes arrow shafts? Carbon fiber arrow shafts?
I don't know about the brand name, but they're just carbon fiber tubes, the cheapest ones I could find. But.
Okay. I have some cutout. Somebody that was making carbon fiber arrows wound up with a
no, they're not for arrows. No.
Okay.
And these are hollow tubes, not rods. Yeah.
But I always wondered whether those would make good structural members for, an arm or, structural material for a rover of some sort because of the stiffness.
Yeah. They're pretty good, but I think the tubes are lighter and still very strong.
Yeah.
Where do you get them from?
Amazon. These are 10 millimeter diameter tubes. And so the interesting thing, this robot here decided the geometric center is in the center here. That little. And so when it rotates, if you want to rotate and position it, it'll go exactly like that. And so it has a good geometry to it. So exactly, if you fit into a space, you can rotate and know that you're not going to bump into anything because you've been there already. Mm-hmm. And it's going to be a precise rotation. And basically the odometry pods will be lined up to the center. So everything's going to be very aligned to that center point so that all the math should work out really well.
Mm-hmm.
So my show and tell is putting the battery in. Here's the battery, and you can't see very well, but it slides into this V mount here. You can see a V on here.
That's the one you showed last week, meant for mainly for AV stuff, right?
Right. Yeah, for photography. Yeah.
High-end cameras.
Yeah. So I'm going to plug it in and put it on the ground.
What's going for a gold star?
Yeah, that's what it looks like.
Right. So the lights came on the power supplies. I haven't figured out the startup time yet. Oh, there it goes. So I programmed it like the outer wheel is 50% and power of the inner wheel is at 30%.
Nice.
So it's doing a nice little round circle like that. I thought this would be more interesting than just spinning in the spinning. So I think I got some pretty good mechanics going on here.
Gold star for Mike. Look at that.
Yeah, Mike's got a gold star. Put it in the chat so I don't miss it.
So I hope to get the odometry pods mounted so that it has actual casters instead of. And then I want to and also and then in terms of coding, I'm going to put the odometry from the wheels I'm going to use for speed control, so I can give it a velocity command like meters per second, and it'll actually run the wheels at precisely that meters per second, which is what Ross really wants to do, is give a velocity command with very high precision. And then the odometry will give you correct the little errors that occur, like time errors and stuff. And I'm not sure if I'm going to put micro ROS in that Raspberry Pi Pico, which runs the motors and the encoders, or if I'm just going to do a serial interface and put the ROS node in the Pi. So I got my Raspberry Pi here that I took out. And so it's going to be a Pi 4 with a screen. So I'll be mounting it on the front of the robot, give it a little face. So
Very
it'll be
nice.
fun.
If you want to do the micro ROS, you are going to have to look at or if you want to do the micro ROS on the Pico, you are going to have to look at getting the Wi-Fi version of the Pico. It's the Pico W. They're real cheap. They're $6. You can get them from Micro Center. I just bought a couple, but I can't find one. So, but they're pretty good.
Yeah, I figured to do the micro ROS over serial.
Oh, yeah, fair enough. Yeah.
Yeah, and I think I'm going to run power to each module instead of trying to power everything from the Raspberry Pi. Instead of like you could build it and run it out and power it from the USB cables from the Raspberry Pi to the modules. But I think that you're going to get to the limit of what the Pi can handle. So
Yeah, probably so.
I'm going to run 5-volt power to each module also. That's my plan. So. All right, I better get the battery out here. So then I can just pop the battery out. So the battery works. Oh, one thing I noticed when I did this is these are 14.4 volt batteries. And when they're fully charged, they're like 16.5 volts. And my first attempt of running the wheels with the battery, the wheels weren't working. Like the motor driver can handle 22 volts, and the motors are 12. So I figured, at 14 or 15 volts, they'll just run faster. Well, they don't. I took my lab supply and cranked it up, and about 13 or 14 volts, then the motor started acting up.
Really?
So I had
That's kind of unusual.
That's unusual. Yeah, it's real unusual.
Yeah.
Right.
I've never seen that too.
At a different point, so they don't. And then you read the spec on the Pololu 12D motors, and they say you put too much voltage on them, they can limit their life or something. But never said that.
Yeah,
That's probably true. Yeah.
That's probably true. Yeah, but I've run Pololu motors pretty hard. So.
Yeah, but they don't like 14, 15, 16 volts. They just sort of say, I'm not moving. I'm not turning, or they turn real slowly and you have no power. I thought it'd be the opposite. It'd be running too much power.
Right.
So I use
that doesn't sound right.
Yeah. That is a weird one.
Yeah, so I went to my lab supply and just wrote and put it up, and it it's running.
I mean, the motor
Maybe one of the caps isn't rated for high enough voltage or something. Like on
there's no caps in the motor. In the motor itself, it's just the armature and stator. I mean,
yeah.
Yeah, but I thought the Lulu motors had noise protection, so they have like 3 caps on them on the back of.
Oh yeah, that could possibly make that. But I wouldn't be surprised that they're that close.
Yeah, me too.
One motor went to 14, one went to 15 before it started acting up. So there's that sort of thing. But so I bought a handful of these little regulators, adjustable regulators on Amazon. And the first one I tried didn't work. And then the second one I tried, I did it for 5 volts and it worked pretty good. And then when I had this motor issue, I just used another one of them for 12 volts. So I'm regulating my battery down to 12 volts using a regulator. And I think that's going to solve all my problems.
Mm-hmm. Okay. Well, I'd be interested to know why that happened, though.
Yeah, that's a strange one. I don't get that.
I guess I could ask Pololu.
Yeah.
They might have an answer for you.
Yeah.
But that's just,
Well, that's the, what series motor is that? The 20?
25.
25? I'm really surprised.
Yeah.
It's like an inch in diameter.
And and I'm doing the low power version, which was just enough because I measured this robot as 3 pounds, and I think when I add everything else, it's going to be 4 pounds or just a hair above, which is what my goal was, to get to 4 pounds. So I sized my motors for 4 pounds. Nothing else. I'll have to go to a medium power motor instead of a low power motor and draw more current. But it'll fit mechanically in the same place. 25Ds.
Yeah. Do they have encoders, right? Oh,
Yes.
I'd be curious if you had, like Ray said, the only thing I can think that could possibly be doing it is the capacitor to ground. I mean, but they recovered. That's why it doesn't make sense. Otherwise, if you went back down to 12 volts, they work fine.
Yeah.
The only other thing is unless they're putting something, like an MOV in there.
Or a Zener maybe, or something.
Yeah, something like that. Huh.
It's not
But even
driving.
Zener,
It's not
you get
a lot of current. It's not like overcurrenting or anything. It's just it just says, I'm not moving. It has no power.
That means it's not getting any voltage. So something's shorting the voltage out, which would, which should be very hot.
Yeah. I touched
either that or it's opening up. That's another possibility.
Something's opening up. Yeah. Oh, well. 12 volts fixes it.
You might want to pop the encoder cover off and take a look and see if you see any scorch marks or anything. Yeah.
Give it the sniff test. See it doesn't. It smells burnt. Then
maybe.
Something went wrong.
Yeah.
Okay. I gotta get something. I'll be right back.
Okay.
All right. I'm done. Thanks.
Cool. All right. Good progress there, and a gold star. That's the first.
Yeah.
We don't have so many these days. So lead the way. That's great.
Yep.
Now we have to see. Ray went off to get something.
I can spend a little time on some Spark Fun purchases I just made. Well, it looks like he's back.
Oh, okay. We'll do Ray, then Spark Fun.
Okay. Anyway, I got off my wallet, as they say, and bought some Go Build the stuff.
That's cool.
This is for the outdoor, competition.
So you're getting serious, huh, Ray?
That's right. Yeah. There's a lot of individual pieces that go into one of these frames, and I thought I had enough bearings. There's a shaft here that sits on 2 bearings, and the motor shaft sits on 2 bearings, and thought I ordered enough. Apparently I did not, so I've ordered more bearings so I can finish assembling the other sides. It'll be the reverse of that side. So.
Mo bearings, mo better.
That's right. Anyway, so
So Ray, what's the shaft?
It's actually, they call it the Rex shaft. It's an 8 millimeter hex shaft. So everything is
Is that a hex shaft that's been milled out of a 8 millimeter rod, or is it sized so that the flat to flat to opposite
flat to flat is 7 millimeters, and then it's rounded on the corners so that it fits in an 8 millimeter diameter.
Okay.
Yeah.
Right.
So you can use 8 millimeter bearings then?
Yep.
They actually have special bearings with this hex profile on the inside.
Oh.
And all of their, well, not all of their parts, but you can get a lot of their parts like these. I don't know, just pulleys, I guess they are.
That would be a lot better than.
But it'll work with any round 8 millimeter inner diameter bearing.
Yeah, it will, but
that means that would be
fit in the holes that are, I think, don't know if those are 14. Yeah, those I think are 14. So the bearings fit in the holes. They have a collar that, catches it so it won't fall through the hole. And on the motor side, the bearing is actually trapped between these two pieces here. And this one I think is maybe a little redundant because the motor has a bearing in it too. So on the output shaft.
So Ray, did you buy new motors too?
Yep, new motors. Those are the Saturn planetary ones. So it should be powerful enough. I got enough hubs, and I'm going to try to put the 10-inch wheels that I used on the other platforms on this.
Now, remind me again on the 10-inch wheels, what was didn't they have like a half-inch or something?
Yeah, they actually have they had a sleeve, a plastic sleeve that the idea of the wheel was actually 3/4 of an inch, and that brought it down to 5/8. But I popped those out and used, 3/4 inch shafts to make basically a shaft adapter between those other servo motors that I've been using and, the ID of the wheel. So
what I'm trying to get at is because I just bought some 10-inch wheels from Amazon, and I'm curious. And I want to say their hub is a lot bigger than 8 millimeters, and I'm trying. And I'm trying to figure out if I'm having an 8 millimeter shaft coming out of the robot, what size realistically can I go to before it starts being weird? I mean, can you go to I would think you could go to a 12 or a half inch.
Yeah.
I'm not sure you can go to 3/4. That would be 18 millimeters. So that'd be 10, it'd be over double.
Yeah, I'm kind of willing. I could show you what the hubs look like. They have a pretty good spread on them. I'll go get one. And it's actually going to bolt to the side of the wheel.
Go Build also sells a 12 millimeter Rex shaft, so same concept. It'll fit in a 12 millimeter hole, which is almost half an inch.
Yeah. So sounds like.
And then you can get adapters to a half inch.
Right. Okay. You got it.
Anyway, that's one of their hubs that they offer. So it has some pretty long arms that'll go, certainly past the hole. It actually has like a hub component on it, but it's a little too big for those wheels. So they're actually going to be bolted to the smooth face.
You still need something going through the wheel to keep it centered if you're gonna use one of those.
Oh yeah. I was just going to make an adapter. I've got a piece of 3/4 inch round aluminum stock, and just go between the 3/4 inch and
Do you have one of your tires not attached to a robot by any chance?
No, I don't. Not here.
No, what I was curious about is how much the wheel weighed. Because when I got mine, I was a little surprised at how much the wheel weighed. So,
yeah, I don't know how much they weigh. They're fairly light because there's no metal in them. It's all plastic.
Yeah.
Yeah, I don't know how much they weigh.
Okay.
So that was one of the things I got. Also got a bunch of these little. They're that one's rated at 5 amps, and it's got a little display on it that shows the voltage and the current, and you can use them for battery charging. I don't know if I'm actually going to get 5 amps out of it, after seeing that video of the guy that tested some of the DC to DC converters that like Mike was using on his platform. I think he got maybe, 60% of the rated current out of the thing. And because the main integrated circuit was a copy, not an ST original or something. But
TI original.
Oh, it was TI, not ST.
No, ST is not TI.
Oh, yeah, no, I knew that, but I thought it was an ST
No,
device. No?
it was a TI device.
Oh, it was. Okay.
Yeah, the motor, the chip that's supposed to do the step down.
Oh, okay. So it was a TI part. Anyway,
supposedly, but it wasn't.
So are those motor drivers, Ray?
No, they're just DC to DC converters with the little LCD display on them.
Nice.
Yeah, cool. Nice.
Anyway, so I ordered 5 of them, and they were supposed to be rated at 5 amps. And the first box I open is this one, which is, you can see it's quite a bit bigger, and it's got a bigger heat sink. This one was actually rated at 12 amps. So I told them that, I ordered 5 of these. I got, 4 of these and 1 of these, even though the box is the same and everything. And so I don't know if they're going to send me another one of the ones that I actually ordered and just tell me to keep that one or what. But it turns on, so I guess I can't complain too much.
Yeah. Well, I think I would have kept my mouth shut and used the one that's the big overdrive.
Yeah, it's rated at 12 amps versus 5 amps. So,
hey Ray, something I've been meaning to ask you since I saw your robot at the contest was what are those motor drivers that you use?
Oh, those are RoboClaws.
Okay.
Yeah, they're the one. Actually, I had an issue with one of them. It was a 2x30. I actually sent it back to RoboClaw. They have a very good warranty. If you break it, typically you can send it back and have them check it out and basically either rebuild it for you or replace it.
Oh.
But I actually have a 2x60 amp on it now because I couldn't use the 2x30. But on the 2x30, the BEC was kind of floating around between 5 volts and 4.3, and it's supposed to be, usually it's very solid 5 volts. So
are they dual channel motor controllers?
Yeah, two channels at 30 amps each.
Oh, I thought you had 2 of those circuit boards on your robot.
No. Nope, it's a RoboClaw. 2 of those circuit boards. Yeah.
Okay, maybe I maybe I looked at something and thought it was a motor controller and it wasn't. You had 2 blocks that had largish heat sinks on them.
Not on mine. There was just okay. It's got 2 heat sinks that are more or less side by side, or it's actually one piece of aluminum.
Anyway, RoboClaw 2x30 or 2x60. That's what I needed to know, because I want to put something like that onto Mobot and just let the mower attempt to drive the motors at full speed, because I'm not getting a fast enough loop time through the mower diagnostic control, and then I'll modulate the motor power myself with something like that.
Yeah, they're really nice. I mean, you can you hook up the encoder outputs to it. You can have it generate the PID coefficients for you. There's a little test loop that you can put it in to do that. You can pretty much give it a command to accelerate at a certain rate to a certain velocity and deaccelerate to a position if you want, based on encoder counts. And it's just one command and send it off on the serial port and it does it for you.
I'm using the 7 amp or 5 amp, 5 or 7, I forget, version.
Yeah.
And right now, I mean, just for the initial test, I'm using it. I've used it in RC mode to verify that the motors and the battery and everything's working properly. But I've been using it from the Arduino in servo mode and that seems to work. But the next step, I've got the Arduino libraries for it, is to run it in packet serial.
Right. Yep.
Are you finding that very difficult to do on your 30 amp version?
No, they're pretty much, it's the same on the 60 amp version. You know, it's the same set of commands. It's just that the one can handle, you know, about twice as much current as the other one. No, it's pretty nice. You don't have to get involved in loop timing because it also takes care of that for you. So.
Yeah. Are you using for the PID? It seems like they can auto tune that on board, but they also have a standalone software package in that runs on Windows that you can connect through the USB on these things. Which of those did you use to tune the PID?
Yeah, I use their GUI that runs on the laptop, and there's I think there's like 1, 2, 3. At least 3 different pages that you can do. And if you're going to do position commands, there's also, I think they refer to it as a PIV loop or testing that you have to get coefficients for too.
Yeah.
So, but it's you just hit a button that says auto tune and it does it. And if you like the way it performs, or if you don't, you can change the coefficients too, and then
I assume you have to do that. I mean, to get the integral and the differential right, I assume you have to do that, in situ on your robot.
Right. Yeah. Okay. Whatever load conditions, the weight of the robot, and of course, I didn't do the outdoor robot outside. I did it on the carpet, thinking maybe, okay, the grass will be similar to the carpet. Maybe, I don't know. Anyway, it seemed to work. It's very smooth.
Does it? I see it supports quadrature encoders. Does it support just single pulse encoders as well?
I thought it did.
Okay.
I haven't used it in that mode, but
okay.
I thought it did.
Okay.
I think there's a mode where it's only counting the one encoder.
Okay.
It's only counting one of the 2 lines that are coming in for the quadrature.
Okay.
Yeah.
But it's been a while since I read through the manual.
Yeah.
I'm not to short it.
So. Yeah, I've always used quadrature encoders, so I don't remember which, the other, I thought the other mode was supported, but not for certain. So I just, it's kind of Black Friday, Cyber Monday time, and been trying to get stuff for as little money as possible. So I got a bunch of, these are the 3-phase motor controls that, because I have 2 hoverboard, I have 2 hoverboards or 4 motors now that I can drive these with. And the other outdoor contest is I've got the 2 hoverboard motors mounted on this, basically a big, it's like a U-shaped channel of a piece of plastic. And those are the hoverboard motors that are mounted on there. And basically just use the hardware that they used to mount these on the inside of the hoverboard. It's really kind of nice. You can even use those as a template to drill the holes. So, it's the thing of, you're going to hit the hole in the right spot, or is the thing going to be twisted or a little off? And so that really helped with that.
So those are brushless?
What's that?
Those are brushless motors on that one?
Yeah, they're from a hoverboard.
Okay. They're hub motors, yeah.
Yeah.
Okay.
And those, I've tested the drivers. They seem to work pretty good. So, 2 of those drivers will go in here. and, you know, pretty much all the other electronic components. And then I'm going to have like I'm actually using it's basically a plumbing fitting to raise this up a little bit and have another piece of this channel come off the back for the caster. So, because I want to get the biggest caster that I can on the back wheel, so it doesn't fall in the cracks and act like a spike on Steve's lawn. So, and what else did I get? So I got a bunch of processors that ESP32s that actually had a battery connector on them. So what I've noticed is the little regulators on the ESP32 boards that I have, especially when you're transmitting, the 3 volts, 3.3 volts goes down to about 3 volts. And so I've noticed that the ones that have the battery connectors and do battery charging, if you do have a 3.7 volt battery hooked to it, the battery is able to source a lot more current than the battery eliminator circuit and long wires and all that can source to the board. So it should work, a little bit better. And let's see, what else did I get? I got a bunch of, instead of the OLED displays that are 128 by 64, there's another one that's 128 by 128, and it uses a different driver. Instead of the, I think it's SSD 1306, it's the 1105, and apparently the 1105 has internal memory in it, so you can pretty much run it on any processor. So, the other thing I got, a bunch of 2020 aluminum pieces. I got 5 1 meter length pieces, and I was going to try to put together a plasma table to use with my plasma torch, and found I was going to use, there's all kinds of different methods you can use. I think the cheapest is to use, the V-Groove, 2020 V-Groove, and put these on it. This one's got 3 rollers, and one of them's got a cam on it, so you can, play with the tension on the rollers. So that rides along the, the 2020 slots in the V-Groove. I don't know if you can see it, but these are kind of chamfered on the edges to match with the chamfer on the V-Groove, or on the 2020 stuff. And I found a NEMA 17 motor mount that, made up with these holes. These are a centimeter apart. So that works good. And this one actually has the little belt loops, right here and here. And that's another way that you can drive the thing down the rail, but I'm not going to use those. I'm going to use the one piece of belt that kind of goes, underneath this roller, goes on top of the, the cogwheel on the stepper motor, and then underneath this one. So you have a strip of the belt that runs along the slit, up and over the cog, and then back on the slit. So on those type drivers. So And I could have a third axis on it, just to, like plasma torches, a lot of times you want to actually touch the metal to start it and then pull up after, the arc is moving and or flowing or whatever. And, so this stuff came from Xyltech. They're in Houston, or out of Houston. They have some pretty good prices on that kind of stuff. So they're actually corner pieces, but I'm going to use them as little, feet or legs for the thing. One in each corner. And what else? Yeah, those are the little plates for the NEMA 17 motor that you bolt to, this other thing, the carriage. So,
hey Ray, can you put the source of that you said? You said it was in Houston.
Yeah, they're out of Houston. Xyltech is the.
I can't see that.
Can't see that. Okay. Yeah. Okay. Yeah, I can put a link in there.
Okay, that'd be great.
So just trying to, like I said, hit all the.
Are you going to use a water tank, or are you going to just use?
Yeah, I was actually going to use a. It's like an auto. You get them from Walmart's. It's a drip pan for. Older cars that have leaky transmissions, or
Yeah.
So, one of the guys that I worked with, one of his daughters had a boyfriend with an older car that he said it would mark its spot when he parked it out on the road, and he didn't like that. So whenever he showed up, he'd bring one of ththose oil pans out and shove it underneath it.
Yeah.
To keep it from, making multiple spots all over his, in front of his house. So it's like, okay, yeah.
Yeah, I use one of those oil pans under my 922 lathe.
Oh yeah, right. Yeah, they work pretty good. So I was going to try to, incorporate that as a pan. Hopefully it's going to, It may hold like a half inch of water at the most. And hopefully it's not going to leak, but,
until you hit it with the plasma torch.
Yeah, right. Blows the water right out of it, or something. Yeah. So, but that's the poor man's plasma table, setup.
Yeah.
It'll be cool.
One of the things that I've been wanting to explore, I haven't done it, is using my laser cutter to cut, templates so that you could essentially. So let's say you wanted to draw, something simple. You wanted to do a 5-inch hole. A 5-inch circle.
Right.
Well, your offset from the center of your tip to the edge of the ceramic is maybe a 1/2 inch. So you just cut a 6-inch circle in your in your laser cutter, out of cheap wood. Slap that on a piece of metal, and then just go. And then it would cut it out.
Yeah,
that's what I wanted to try.
It beats using thin strips of wood that you may be able to do maybe 3 cuts with before it's so charred. It's not not a flat surface anymore.
Oh yeah.
I've done that before. So but
okay, well that's cool.
Yeah,
you're gonna have to take a little video of when you get finished on that project. That'd be cool.
Yeah.
I assume you're going to have it like CNC.
Oh yeah. I've got an old. I think I actually have 2. One's I think Protoneer was the manufacturer. It actually was like a ramps board that sat on a Raspberry Pi, and so you could bring programs over on a USB stick and, just plug it into one of the USB ports and, go that way, or use an SD card into the other board. So, but yeah, I've had both setups for a long time for a plasma table, but never got around to buying the stuff for it. So, but anyway, hopefully it'll work. I'm a little worried about spatter. Like if you initially blow a hole somewhere in the interior and then go out to the actual interior edge that you want to cut.
What they recommend is that you drill a hole, because where all of your tip gets fouled and goes bad on you is if you're trying to cut a hole, that's when it shoots back. They always tell you to start at an edge if you can. Yeah. That way, when you come into the material, it's just cutting and there's no blowback. And the other thing they recommend is, so like if this is your flat piece, you can sometimes start a hole by going sideways so that the blow is off away from your tip. But that's more tricky. But if you got to do something interior, even if it's off your geometry, just drill a hole and start over that, and then because then it's like you got your own edge.
Right. Yeah, you got the edge.
How thick of metal are you going to be cutting?
I think the torch will do up to 1/2 inch. I don't. I don't know if I'll ever need something that thick. But
what I found on mine, I only have a 35 watt plasma cutter. And what I found on mine was that if you're doing something like a 1/16 or 1/8 of an inch, your slag is almost nothing. It really is a clean cut.
Yeah.
And you try to push that thing to, in my case, it's about a 1/4 inch. Then it'll cut it, but it's kind of nasty.
Oh yeah.
In your case, it's probably a 1/2 inch, and it's kind of nasty.
It might be. Yeah, like I said, I don't know. Most of the stuff, I don't think I've done that much with 1/2 inch stuff. It's
that's me either. In fact, I haven't done hardly anything with over a 1/4 inch. You know what I mean?
Yeah. Yep. Yeah, I actually made a heat exchanger for my fireplace and cut. That was out of 1/8 inch, and the cuts were really nice. I didn't have a CNC table to do it with. I just did it by hand, but they came out. I thought it's very clean.
Really nice, very nice. Yeah.
Yeah.
The edges are surprising.
Yeah.
It's a cool tool.
Yeah. So I don't know what plasma tables are running these days. Probably still thousands of dollars, but
One of the things I have seen them do is they grab the cheapest 5 watt laser engraver they can. Okay.
Yeah.
And then they just take the laser and go ka-chunk.
Cannibalize it, yeah.
And put it on there.
Yeah.
I don't know how long that would last, but I definitely would last at least one cut.
Let's hope. Yeah. I found it was a 65 by 50 centimeter, engraver. And that was for like 119 without a laser. But still, okay, let's see, 65 is, what is that, 24? That's like 26 inches by 50 by 20 inches. And so I was, able to do a meter by, it's going to be a little bit less than a meter by a meter, but I could at least do 3 feet by 3 feet. So with a little bit of, I can probably do a little bit more, but you obviously can't run that bracket to the end because it has it's not zero width. So it's going to take off from either end, maybe, I don't know, probably an inch at least, maybe an inch and a half. But so, yeah, it's one of those bucket list things. I had other pieces that have been sitting around, lead screws and other, other slides for forever, and they were a lot, smaller than 1 meter by 1 meter, and I just decided, okay, I'm just going to get the 2020 stuff and see if it works. And I thought, there was some. I saw. I'm not certain what it was called. It's got I guess they just call it like a drawing table, and it was similar to the stuff that we did, for that contest. But it'll draw on a larger sheet. It actually has 2 servos, and it hangs. It uses fishing line. Yeah. So they had one for like $39 on AliExpress, and it included everything that you needed, even the Uno underneath the driver board, and the steppers, and a 3D printed pen holder, and all that. But I thought, okay, now skip that. So.
Yeah, I'm not sure. That's it. I've seen those, and they draw good, but I don't know if they can do much more than that. Though I did see there was like a independent company, it's a garage company that made a CNC that their big claim was that it was vertical like that, and it used one of those hangers. But I don't
really.
Yeah. They were actually using a router, but it was kind of weird looking. I don't know, maybe. So I guess it can be done.
And the router actually hung by cables or something?
Yeah.
Wow. You'd think it would push it around with.
Well, they might, they probably had like something like Omni wheels underneath it to hold the spacing.
Oh, okay.
I'm just guessing. And high speed router so the cut was. I mean, I'm just saying. I didn't say it was successful. I just said they made it and offered it for sale.
Wow.
Yeah.
My luck could catch a knot in the wood and just throw the router across the room.
I've always been worried about with the plasma cutter. It's just like cutting off your foot or something. Going like, oh well. What?
Yeah.
Whoops.
You just felt the pain for just a second, but that's all it took.
Yeah. And then it's cauterized.
That's right. Yeah.
That would be splatter rather than spatter.
Oh yeah. Anyway, so I don't know if you guys try to make use of those sales, but like the Go Build a stuff was 25% off, and so much easier to justify it at 75% of the original cost. So
but I did my shopping at
Yep.
Friday.
Anyway, so that's pretty much what I've been doing, is following up on all these things, and
Yeah, you got plenty of projects for the new year.
Yeah, it's like I'm loaded up now. Got all the stuff, and hardly any excuses to make. So
yeah, I know what you mean. When you said the part opened up your wallet, I knew that. I know, and I'm talking to you, brother. I know.
Oops.
Cool. I think that takes us to open mic.
You guys.
I was going to show some of a few things that I got from.
All right.
Okay, if you guys are going to use Adafruit has something called Stemma, and SparkFun has something called, I think it's QWIIC.
Quick
connectors. They're compatible with each other, and they're used to construct I squared C networks to different things. And anyway, I thought I would show you guys some things. Since I've been playing with I squared C for the last couple of weeks. Cursing it with great passion. Anyway, as my robot build that I presented earlier, one of the things that I was going to explore was using a Raspberry Pi 02W. That's equivalent to like a Raspberry 3 Plus, I guess. And I wanted to use that on my OD Lite. So this is what the board looks like. It's nothing. It looks exactly like a Zero, except it's got, a Wi-Fi module on it. But it is a multi-core, and it's got a few other nice features. $15, the same price as if you go down to Micro Center and get a Raspberry Pi Zero, same price. There's no. So you might as well get the two if you can. Well, the only person I found, I found it on SparkFun, $15. But they only let you get one. And the other problem you have is that shipping is $15. So, well, I said, I really want that board, and I couldn't find it anywhere else. Not you guys can probably tell me, well, you could have got it, blah, blah, blah. But anyway, when I was looking, I couldn't find it. So I got it, and I got the little USB, it's an OTC cable, so that it can plug into here and give you essentially one USB port. So that's what I was buying. All right. But so I started looking, I said, well, let's look and see what they have for Quick or QWI squared C. So then it turns out that when they started going that way, SparkFun's got all sorts of stuff. Like, I don't know if you can see this. What this is, it's a Quick shield for a Teensy 4.1. So it breaks out the 2 or 3 I squared C ports and puts them out onto Quick. And so, well, what if you don't want to go there because that's $31 a board and you want to go with something a little cheaper? Well, for $17 a board, you could get your Teensy 4. Well, they have the same type of thing for Teensy 4. So, gotta have one of those. Well, what if you don't want to do that? What do you want to do it on Raspberry Pi? Well, they got that too. Well, then if you really, really wanted to get something different, what about a Nano board? Like a Arduino Nano. Well, guess what? They got that one too. Damn. So anyway, so now I've just about got it up to where I can say, well, I didn't pay the same amount of money for shipping as I did for what I wanted. Their strategy won. I ended up paying more, and they have some okay, so you got something with DuPont cables, and you want to go to Quicka. You got one that you want to have a whole bunch of Quickas tied together, and I got that. You want some level shifting Quickers, where you go from 5 to 3.3. They got that too. So anyway,
Doug, is this the foundation of a new contest? Maybe a robot that uses exactly every element you bought with $100 from SparkFun?
Yeah, probably. Now, okay. Anyway, I just thought that was. I guess what I really wanted to tell you guys was I was surprised at all the stuff they had. And then there's one last thing I wanted to show you. This I'm intrigued. This is available out on Amazon. And they have it for 2S, 3S, and 4S. And it's a charging circuit that will do quick charge. So it'll actually pump the voltage up to like 9 volts and give you more current, more watts. I shouldn't say current. And it has, so your inputs are either a mini USB or USB-C, and the outputs are basically wire. And they're very reasonable. I'll put a link in there for that.
Yeah.
And, because what I was thinking is I want to have this, one of the things I want on that robot I was telling you about earlier is I want to have it so that the charger is built inside of the robot. I don't care if it charges fast. I just want it so that I don't have to keep taking the battery in and out.
Yeah.
So anyway,
So are those limited to like a half an amp or something, or?
I want to say they're at least 15 watts. So,
So 3.
I don't know. They got 2, 3, and 4. So I'm not sure exactly. Well, it should still be 15 watts going in. I don't know. Say 85% efficiency. Still, it's reasonable.
Yeah.
I'll put a link into the chat when I hear in a second.
Do you have to build a balance cable to make sure you're working?
Well, you should. Okay, you should have a balance cable. Well, and I would think that you would periodically balance your battery. But I was thinking more of something like I probably would do that every other time or so. So I'm not using any balance. These do not come with a balancing cable. Okay, so they're going to just be like if you disconnected your balance and did a charge. Okay, so it really depends partially on your battery condition, whether you started off with balanced charge. Like I say, I just want something that if I want to, let's say I got the robot and I decide I wanted to just give it a little charge. Could you work out a balanced charge? Yeah, you should be able to do that. Not on these, but on something else. Anyway, I'll put the link in if anybody's interested.
Sure.
Yeah.
I've been trying to think of ways I could wirelessly charge those, like to a big loop. But I haven't. There's some stuff on YouTube where people are trying to do that, but I haven't gotten that far yet.
Yeah, you can buy those type of chargers pretty easily.
For like a trickle,
Yeah.
But then I got some iRobot charging stations that might make more sense for me since I already got those. Just filling the contacts.
Oh, okay. So you're using the charger base to charge your battery.
Yeah, I bought one of the first iRobot, the iRobot 400, I think it is. And the battery went out on a long time ago. I just got a new battery for it, but it might become a robot here pretty quick. And it's got its own, IR beacon charging station to work from.
Yeah, this actually, you can get one of these if you go to last year. If you go to the Chevrolet booth and drive a car, you can get one of these chargers. That's an inductive coupled charger. So I think you have to drive 2 cars actually to get one. So that was the deal.
My arms aren't that long. I can only drive one at a time, I think.
Yeah.
They do have them on Amazon too, where it's literally just the inductive coil and the driver PCB. I was looking into some of those for a separate project of mine, but they're pretty readily available and they're actually decently cheap. I think too, they actually just came out with one of the new fast charging standards, quick charging, whatever it is, over wireless, QI2 or something. And so that might be something to look out for too, especially with the larger capacity of some of those batteries.
Yeah, I know those are out there. I'm just not sure, like for a, 2S, 4S, 6S battery, if you're getting enough oomph out of it to actually charge those, in less than the time the robot's going to be around. But I don't know. Maybe so. I don't know.
Kind of curious about that, how well, this actually couples to what you're trying to charge. And, I thought you'd have, if you don't have very good coupling, I'm sure that the amount of power transferred goes down pretty quick.
Yeah, you'd have to drive it into a wedge that made damn sure you were, lined up, get that to work. But even then, if it were lined up perfectly, do you get enough, inductive coupling to, make it worthwhile? I don't know. That's
this one, I guess input was 5 volts and 1.5 amps, and output was 5 watts. So
that's not too terrible, I would guess, for like a, if you're just going to be parking your robot in someplace overnight until it's needed again.
Yep.
Apple has wireless charging built into some of their newer iPhones, and actually they tried to solve the issue of aligning the coils to get good coupling with this ring of magnets. It's called MagSafe. And I'm almost certain there's probably some design specification for, whatchamacallit, like accessories that you can maybe find out there that Apple's published that might also kind of describe the, the expected power output of something like that. I don't know.
Yep.
Well, what would you use for the receiving end? That's the bit that emits the power. What would you use for a pickup? Like, are there any off-the-shelf thingies that you can pull a decent amount of power out of?
I think SparkFun has a kit that does that. So you have a coil on the bottom and a coil on the top, and so you line up the two coils where they're inductively coupled, and then that it's basically a transformer at that point. So you basically build a small switching supply that takes that inductive current and turns it into a voltage that you charge your battery with. And they've got little examples.
Yeah, I understand the principle, but there's details like how many turns do you need on the receiving coil, and what's the frequency, and a lot of details. That if there's some standard thing like a SparkFun module, that would be good.
So
Paul, there's a standard out there that drives that stuff, but there's a module. I saw a module at SparkFun that basically conform to that.
Yeah, I think they're on Amazon too.
Here's a pair. I just put a link on Amazon. $10 for a pair.
Yeah.
Oh wow.
Okay.
Yeah.
That'd be worth playing with, I think.
But yeah, you got to add that to your list, Doug, and no extra shipping if you're on Prime.
If you have one of these, it's a whole lot easier. You just don't have to worry about it.
They have some bigger ones.
Yeah, it'll just be interesting to see. Like I say, I don't know if they'll pan out, but I thought it'd be fun to try them.
You want to see some DPRG history?
Sure, if you got some history, because we try to capture that on the website.
Okay, so this this right here is an IR proximity. At one of the RBNOs in 1998, we made these, and it says right there DPRG and IR prox.
Okay, now, hey Brad.
Yeah.
I need some help here. Can you go ahead and send me my email's on the website. I'm under be secretary at dprg.org.
Okay.
If you can send me pictures of that and a little story about it, I'll put it in our history section.
Okay. We actually built those. We etched those out.
Yeah. I've seen a similar project, which was a motor driver.
Like this one right here.
Yeah, yeah.
That's the motor driver. So those are L290. We made a batch of those, and we made a batch of the IR proximity detectors.
Yeah. Well, if you can go ahead and like I say, document both, and if you got dates and talk about maybe a little bit about when you say you were at Robo Builders Night Out.
Yeah.
You know, like what facility were you in?
Oh my God!
Were you in the workshop? The one that was okay.
So back then, we had like a rented space, but most of those wound up. There was a guy in Rowlett, and I can't remember the.
Yeah, I know who you're talking about.
Yeah.
By the way, he's dead now.
Yeah, I heard.
Yeah.
I think it was Jim Brown.
Jim is for sure. The last project that I did with, we did a big 10-foot Robbie robot, and that was done in his workshop.
Yeah.
His personal workshop that he had in his backyard, you know, which in a big Butler building, which was like, you know, I would have given, I don't know if I'd have given my son, but, you know, it would have been close. You know, it was a beautiful facility.
Yeah, we etched those out. You know, we had like the central place, and then for big stuff, we would go out to that dude's shop in Rowlett, and that's where, you know, he had like a mill, a standing mill.
Yeah.
You know, 3 axis, I think. This big, good-sized mill that we used out there.
If you can give any dates too, that they don't have to be perfect. Just, you know, sometime in 2000. I mean, whenever it was.
Yeah.
And that would be great. And I guarantee you, I'll get it up there. I'm still working on Pat's. He sent me some stuff for another project, but because of my situation, I haven't been able to get to that. So
we'd have to file that under the.
Oh, hey, Brad, let me ask you another question you might be able to shed. Okay. I'm trying to work up, since we now give Robo Columbus mugs out as one of our prizes. And, but we went through a period of acrylic trophies. And the earliest ones I've been able to track down are the ones that were made by, oh God, I can't think of his name.
Ron
Grant. Ron, he made them for years, but I don't know the beginning date. I mean, I know when I first started getting them, and I wonder, do you remember any of those?
No, I remember. I think we had like some shirts.
Yeah, well,
back then.
I know that I have one shirt because I saw it on Will, and I had him tracked down on it. This is the trophy I was talking about.
Yeah.
This was made by Ron Grant, and he made them for years. It'd be handed out for different ones.
It had to be around 2008.
One because so I'm not the expert on that.
Yeah. Well, I'm just wondering
he used to do them in a kind of plastic that had fluorescent or luminescent.
Yeah, that's what this is.
Yeah. And it had to be about 2008, I would say, maybe 9, because I joined the club in 2007 and
do you remember the first
started
one?
Doing them a little bit after I joined.
Okay, because the one I've got here is 2012. And
this one's 2015, but I think you had them out before then.
Yeah, it had to be 8 or 9.
I don't remember anything like that in 1998.
Like this one was 2014, but this is different.
Good to see it.
Yeah.
Yeah, and we had some that I know were made by Rick Swan, and those were made in 2013. So I don't. I was going to say 2012 looks like the end of Ron's. I think he ran out of plastic or something, and that was the end of him making them. Then I picked it up because I had a K40 by that time, and then Rick did it one year because he has a K40. So, and then we did it through. So I have to look in the pictures to see when we stopped. And then we went to, so now we give out at Robo Columbus, anybody who makes a point gets a specially designed mug, which changes every year. So we've had 3 so far, so there'll be one next year. So.
Well, cool. I guess I'll have to make one of those then.
Yeah, I definitely recommend it. It's all fun. All right, and
so historically, that's the bear skin and bone knife era with these, old printed circuit boards.
Yeah.
This is when you couldn't. This is when you couldn't get them from AliExpress for 60 cents.
You had to hand etch them.
Yeah.
Yep.
Yep.
Okay, you're at the.
Now, if I could just swing in here right quick, I gotta head out really quickly here. Before I go, is there any chance anybody could send through on the chat some recommendations for fume hood extractors for soldering? I had one. It kind of broke down. I'm looking for something that people recommend, and all the lists online are all sponsored, so I just don't know.
Yeah, all of mine are. I didn't use them. Yeah. I don't know. I can't help you on that one. I think anyone is probably better than nothing.
Yeah, I know they have some that, it just sucks it through a filter and exhausts it out the back. And
yeah, that's very common. And the filter is just a carbon filter, so I don't think it's taking the lead out.
Probably not. Yeah. Maybe just burning flux or whatever.
Mm-hmm.
Yeah, I know the Makerspace. I can't think of the brand that they used at the Makerspace, but those seem like pretty good ones.
Mm-hmm.
Does anybody remember their? No. Yeah.
I could probably call them up tomorrow.
Well, yeah. And another thing that you could do is you could search Mauser. Probably anything out of Mauser is going to be good.
Yeah. I was looking at them, and they all look interesting.
Yeah, but I mean, if you look at them, even if you can't afford those, you can see what features they have, and then use that to try to find one that's acceptable.
There's one on Amazon Prime for $35.
Yeah.
I'm a little dubious of whether it'd actually work or not, but
what type of filters has it got, Carl?
I don't know. These, just at a quick glance, they look like they're carbon.
Yeah.
Fume.
Yeah, but they probably have something underneath it too.
Yeah. Yeah. I just searched for solder station air filter.
Yeah.
And
I've got a bunch pulled up here. I was looking to see if maybe y'all had any specific recommendations before I go and buy anything.
Yeah.
So, all right. Well, thank y'all. I've got to head off. So.
Okay.
All righty.
See y'all next week.
Sounds good. Take care. Anyone else for tonight? We've had quite a lot of. This is the longest discussion in a while.
Yeah.
Great discussion.
11 o'clock.
Yeah.
Oh God.
All right.
Nothing for me.
Well, with that, I'm going to make a move to adjourn. And
good night, gentlemen.
You guys have a great night, a great week, and we'll see you next Tuesday night.
Yep.
All right. Good night.
Thanks again.
All right. See you guys.